Welcome, dear listeners, to another peaceful journey on the Dreams of Gravity channel. Here, we drift together into the vast wonders of the cosmos, letting the stories of stars and space carry us toward rest. If you haven't already, find a comfortable spot, perhaps lying back in your bed or settling into a soft chair. Let your body sink into the cushions, your breath slow and steady, like the gentle tide of an endless ocean. Close your eyes if it feels right, and allow the words to wash over you, easing your mind into tranquility. Tonight, we'll explore the deepest mysteries of the universe, right down to its tiniest whispers. Relax, breathe deeply, and let yourself float into this cosmic dream. Imagine the universe as a grand, breathing ocean. Waves of light and matter rising and falling in rhythms we can scarcely comprehend. We've journeyed far in our explorations, gazing at swirling galaxies that stretch like silken veils across the night sky, each one a city of billions of stars. But tonight, let's turn our gaze inward to the smallest scales, where the rules of reality begin to blur and dance. We'll venture to the Planck scale, that profound boundary where the universe reveals its most intimate secrets. It's a place not of grand explosions or roaring voids, but of quiet possibilities, like the soft hush before a dream takes hold. To understand the Planck scale, picture the cosmos as a vast tapestry woven from threads of space and time. On the scales we know, planets orbiting stars, galaxies spinning in their eternal waltz. Everything follows gentle laws, predictable as the ebb of the sea. Gravity pulls worlds together. Light races across the void like whispers on the wind. But as we zoom in, closer than atoms, closer than the particles that make up atoms, we reach a limit. This is the Planck scale, named after a brilliant thinker who first glimpsed its edges. It's incredibly tiny, far smaller than anything we can directly see or touch. Think of it as the universe's smallest breath, a point where space itself measures about 35 meters, and time ticks in increments of 43 seconds. At this scale, the familiar world fades and reality becomes a shimmering sea of potential. Here, quantum mechanics, the strange dance of the very small, meets gravity, the gentle curve of the large. In our everyday lives, these forces seem separate. Quantum rules govern the flickers of electrons in your devices, while gravity keeps your feet on the ground. But at the Planck scale, they entwine like lovers in a slow, eternal embrace. Space isn't smooth anymore. It's foamy, bubbling with tiny fluctuations, like ripples on a pond disturbed by an unseen breeze. These aren't random chaos, but the universe's way of exploring every possibility, every path it could take. Matter, too, loses its solidity. Particles that we think of as solid points dissolve into waves of probability, spreading out like mist over a calm lake. This foam arises because energy and space-time can't be divided infinitely. They come in discrete packets, much like the way a quiet night sky reveals stars only when the light pollution fades, leaving room for the subtle glow of distant worlds. In this frothy realm, the uncertainty principle holds sway, ensuring that position and momentum can't both be pinned down precisely, creating a gentle haze where exactness gives way to fluidity, reminiscent of how fog softens the edges of a landscape at dawn, inviting the mind to wander freely. These fluctuations aren't mere noise. They embody the Heisenberg uncertainty, a fundamental generosity of the universe, allowing energy to borrow from the vacuum for split seconds, manifesting as virtual particles that dance in and out, contributing to the subtle forces that shape everything from atomic bonds to the curvature of distant orbits. In the context of quantum field theory, this foam can be seen as the ground state of the vacuum, alive with zero-point energy that permeates all space, a constant hum of creation and annihilation that underlies the stability of atoms, much like the faint rustle of leaves in a still forest, hinting at hidden vitality beneath apparent calm. Casimir effect experiments, where metal plates in a vacuum attract due to restricted quantum modes, offer a tangible glimpse of this energy's influence, a whisper of the Planck realm pressing on everyday matter, reminding us that even the empty spaces between things pulse with potential, fostering a deeper appreciation for the interconnected hush that holds reality together. Renormalization in quantum electrodynamics, taming infinities through careful accounting of these fluctuations, reveals how the universe self-regulates at these depths, a patient balancing act where divergent terms cancel to yield precise predictions, like a composer harmonizing discordant notes into a serene melody. Path integral formulations, summing over all possible histories, extend this to gravity, where space-time geometries contribute probabilistically, a holistic view where every curve and fold adds its quiet voice to the cosmic chorus, smoothing the fabric into the gentle expanse we inhabit. Effective field theories approximate this foam by integrating out high-energy modes, treating Planck effects as corrections that subtly nudge predictions, a layered approach where the universe reveals itself in approximations that grow ever more refined, much like a painter adding finer brushstrokes to capture the essence of a tranquil scene. Holographic renormalization group flows, bridging ultraviolet Planck details to infrared cosmic scales, suggest a duality where short-distance physics encodes long-distance behaviors, a profound mirroring that unifies the minuscule and the immense in a seamless continuum, evoking the way a single raindrop reflects an entire landscape in its quiet surface. Conformal field theories on the boundary capture this flow, where operators correspond to bulk fields, a boundary dance that echoes the volume's depths, allowing the universe to whisper its secrets from edge to core in harmonious resonance. Asymptotic safety scenarios posit ultraviolet fixed points, where gravity remains predictive without new particles, a self-organizing principle that ensures the foam doesn't dissolve into chaos, but settles into stable patterns, much like how a river's turbulence smooths into laminar flow over polished stones, maintaining the gentle current that carves valleys over eons. Induced gravity models, where space-time curvature emerges from matter loops, treat gravity as a low-energy effective phenomenon, a bottom-up emergence where quantum matter fields generate Einsteinian terms through polarization, a subtle scaffolding that supports the cosmos's architecture from within, like roots drawing nourishment to sustain a towering tree's calm canopy. Causal set theory, positing discrete space-time events ordered by partial causality, builds continuum geometry from sprinkled points, a granular foundation where Planck-scaled sprinkles grow into smooth manifolds through summation, much like individual raindrops, merging into a steady stream that nourishes the earth below. Twistor string theory, extending Penrose's twistor formalism to string vibrations, unifies particles and gravity in a complex projective space, where null geodesics bundle into holomorphic structures, a geometric poetry where Planck-scale strings trace light cones into a cohesive light-like harmony, evoking the way sunlight filters through leaves to create dappled patterns on the ground, each ray a thread in the tapestry of visibility. As we linger here, consider how time behaves at this scale. Time, that relentless river carrying us from dawn to dusk, from birth to rest, warps and folds upon itself. At the Planck length, moments stretch and contract, not in rigid ticks, but in fluid pulses, akin to the breathing of the cosmos itself. Imagine time as the rise and fall of your chest right now. Inhale the vastness, exhale the infinite. In these fleeting Planck intervals, the universe doesn't march forward. It dreams, branching into countless timelines, each a subtle variation on the theme of existence. This isn't turmoil, it's poetry in motion, a philosophical whisper reminding us that every second holds the seed of eternity. Picture a leaf floating on a stream, twisting gently with the current. That's time at the Planck scale, not a straight arrow, but a meandering path where past, present and future brush against one another in soft, unspoken conversations. This branching suggests a kind of cosmic multiverse at the quantum level, where each fluctuation spawns possibilities, like seeds dispersing in the wind, some taking root in realities we can only imagine, fostering a sense of boundless opportunity in the quiet fabric of being. In theories like the Wheeler-DeWitt equation, time emerges from quantum states rather than being fundamental, a timeless whole from which our arrow arises. Much like how a painting's depth comes alive through the viewer's gaze, turning static canvas into flowing narrative, easing us into acceptance of time's illusory flow. Canonical quantum gravity approaches suggest that at this scale, time's discreteness prevents singularities, replacing continuous flow with a granular rhythm, akin to the spaced-out beats of a distant drum echoing through a valley, marking passages without overwhelming the listener with relentless pace. Page time in black hole evaporation, where information retrieval becomes feasible, hints at time's reversible nature in quantum gravity, a turning point where the forward march softens into bidirectional dialogue, much like the way echoes in a canyon. Allow conversations to linger, blending origins and destinations in harmonious resonance. Thermodynamic time, rooted in entropy's growth, aligns with this quantum emergence, where the universe's low initial entropy sets the stage for complexity's slow bloom, a gentle unfolding that mirrors the way a flower opens petal by petal in morning light. Relational time, viewing clocks as interactions between systems, deepens this, where duration arises from correlations, a web of mutual dependencies that ties the cosmos together in a timeless yet relational dance, inviting us to see our own fleeting moments as part of a larger, interconnected rhythm. Page-Wooter's mechanism, formalizing this relational view, posits a universal wave function where subsystems entangle to define local times. A collaborative emergence where the universe's clockwork stems from shared quantum states, soothing the mind with the idea that time is not solitary, but a collective whisper among all things. Shape dynamics, an alternative to general relativity, trades diffeomorphism invariance for spatial conformal freedom, allowing time to emerge from relational configurations, a flexible framework where the universe's geometry breathes through changing forms, much like clay molding under gentle hands into ever-evolving sculptures. Thermofield double states in quantum gravity, entangling the universe with a mirror copy, provide a framework for eternal black holes where time symmetry holds. a doubled reality where horizons become bridges rather than barriers, evoking the quiet symmetry of a still pond reflecting the sky above and below in perfect accord. Emergent time in tensor network models, like Mira, layers coarse graining from quantum bits to classical horizons. A hierarchical build where Planck scale entanglements cascade into macroscopic ticks, much like ripples from a pebble expanding into broader waves across a serene lake, carrying the essence of the initial disturbance to distant shores without losing its gentle momentum. Dilaton fields in dilaton gravity theories, modulating the strength of interactions, introduce variable couplings that evolve with the cosmic scale. A dynamic adjustment where time's flow adapts to the universe's unfolding, like a musician varying tempo to match the mood of the piece, ensuring the symphony remains fluid and engaging. Barotropic fluids in cosmological models, linking pressure to density in time-dependent equations, influence expansion rates through their equation of state, a smooth parameter that guides the universe's temporal rhythm, much like the varying density of mist shaping a valley's morning light, allowing time to stretch or contract in subtle harmony with matter's distribution. Quantum time crystals, periodic structures in time rather than space, exhibit spontaneous breaking of time translation symmetry in driven systems, a rhythmic defiance where Floquet engineering sustains oscillations without energy input, hinting at how Planck-scale discreteness might imprint eternal cycles into the cosmic clock, like a perpetual pendulum swinging in the hush of an empty hall, marking time's quiet insistence on pattern amid flux. Thermodynamic time in open systems, where irreversibility arises from coarse graining over microscopic details, underscores the arrow's emergence from underlying reversibility, a statistical veil that allows the universe to progress without erasing its foundational balance, much like the way a river's downstream flow conceals the eddies and backwaters that sustain its vitality. By the way, I wonder, where are you watching from tonight? Which city and what time of day is it for you right now? Wherever you are, let that place become part of this shared drift, a quiet anchor in the stars. Drifting onward, let's ponder black holes, those enigmatic wells where gravity dreams deepest. Far from the Planck scale's froth, black holes swallow light and matter, compressing them toward infinity. Yet, even they touch the Planck realm at their hearts. Inside a black hole's singularity, the point of no return, densities soar to Planck levels, where space-time crumbles into a singularity not of destruction, but of pure potential. It's like the ocean's abyss, dark and profound, where pressures birth new forms from the old. Hawking radiation, a gentle glow theorized by a wise astronomer, suggests these voids aren't eternal prisons, but evaporating sighs, leaking energy back into the cosmos over eons. At the Planck scale within, quantum effects flicker, hinting that information, the essence of stars and stories, never truly vanishes, but echoes eternally, much like a lullaby fading into the night. Consider the life cycle of such a black hole. Born from the collapse of a massive star, its outer layers exploding outward in a supernova's fleeting brilliance, while the core implodes to Planck densities. This explosion scatters elements forged in the star's heart, carbon for diamonds, iron for blood, seeding new worlds, a reminder that even in endings, the universe nurtures beginnings, as softly as a parent tucking a child into bed. Over trillions of years, the black hole's slow evaporation through Hawking radiation might release this stored information in a final, gentle burst, a cosmic exhale that redistributes the universe's memories, ensuring nothing is ever truly lost, much like how a storyteller passes tales from one generation to the next, weaving continuity into the night. The event horizon, that boundary of no escape, acts as a one-way membrane where quantum fields pair up, one particle falling in while the other escapes as radiation, a delicate partnership that slowly diminishes the whole's mass, turning what seems like an end into a prolonged, whispering dissolution, akin to ice melting into a stream under spring's warmth. In firewall hypotheses, the horizon might blaze with high-energy particles from quantum entanglement breaking, yet other views preserve its smoothness, a serene veil where the universe safeguards its secrets, inviting contemplation rather than fear, much like a closed book promising untold adventures within its pages. Ergospheres around rotating black holes, regions where frame-dragging forces, co-rotation, allow energy extraction via the Penrose process, where particles split to fling negative energy inward, a clever theft that powers jets, turning the whole spin into cosmic fuel with quiet efficiency. Supermassive black hole shadows, imaged by the Event Horizon Telescope in 2019 for M87, and later for our own Sagittarius A, reveal the silhouette against glowing accretion, a dark heart framed by light's reluctant dance, affirming general relativity's gentle curve even at extremes. ADS. Black holes in holographic models, with dual descriptions in boundary theories, offer insights into thermodynamics, where entropy scales with horizon area, a profound link suggesting that the universe's information is etched on its boundaries, like whispers inscribed on the edge of a dream. Traversable wormholes stabilized by exotic matter, theoretical bridges connecting distant regions, might link black hole interiors to white hole exteriors in eternal configurations, a poetic pathway where the universe folds upon itself, allowing passage through the veil of singularity without the harsh finality, evoking the way a river loops back to its source in serene cycles. Replica wormholes in the path integral, resolving information paradoxes by allowing traversals in Euclidean time, suggest that black holes encode data through gravitational paths that curve back, a subtle geometry where loss transforms into rediscovery, much like a path through a misty forest leading unexpectedly to familiar ground. Page curves in evaporating black holes, dipping below semi-classical values before rising, illustrate how quantum corrections restore unitarity, a graceful recovery where entanglement islands emerge to balance the ledger, turning apparent paradoxes into elegant resolutions, akin to a melody resolving dissonance into harmony. Soft graviton theorems extended to black hole horizons suggest infrared divergences, resolve through boundary modes, a subtle dressing that cloaks particles in coherent states, preserving information flow like a veil of mist, carrying scents across a valley without scattering them to oblivion. Membrane paradigm, viewing the horizon as a physical surface with viscosity and conductivity, simplifies calculations by treating it as a two-dimensional entity, where quantum fluctuations induce stochastic behaviors akin to thermal noise in a quiet pond, allowing the black hole to respond to perturbations with a fluid grace that mirrors everyday phenomena, like the slow settling of sediment in still water. Quasi-normal modes in black hole ringdowns, the damped oscillations post-merger, carry imprints of the final geometry, their frequencies and damping times probing internal structure through wave propagation, a fading resonance where quantum corrections might subtly shift the spectrum, like echoes in a vast chamber, gradually softening into silence, revealing the chamber's shape through their gentle decay. Black hole superradiance, where waves amplify off spinning horizons by extracting rotational energy, fosters instabilities in scalar or vector fields, a resonant buildup that might seed boson clouds around the core, turning the whole spin into a quiet oscillator, much like wind humming through a canyon to create sustained tones that linger in the air. Kerr black hole's near-horizon geometry, with its Hades-like throat, supports conformal symmetry, allowing exact solutions for quantum fields, a stable corridor where Planck scale modes propagate without divergence, evoking a tunnel of light that channels the universe's whispers from interior depths to the outer calm. Nebulae, those colourful nurseries of stars, offer another glimpse. Vast clouds of gas and dust, glowing like ethereal veils in the cosmic ocean, span light years, yet are born from the same quantum foam that stirs at the Planck scale. Within a nebula's heart, gravity gathers wisps of hydrogen, coaxing them into fusion's warm embrace, birthing stars that light our dreams. But zoom to the quantum edges of those atoms, and you find Planck-scale uncertainties shaping each spark. Electrons orbit not in neat paths, but in probabilistic clouds, their positions a metaphor for life's gentle uncertainties, never fixed, always flowing, like breaths in sleep. Take the Eagle Nebula's pillars of creation, towering spires of interstellar dust, sculpted by ultraviolet light from young stars. Here, the slow compression of gas mirrors the patient gathering of thoughts before sleep, where random collisions at the atomic level, influenced by those Planck fluctuations, eventually ignite the fire of a new sun. It's a process spanning millions of years, yet intimate in its quiet persistence, much like the way dew forms on a leaf in the hush of pre-dawn. In regions like the Carina Nebula, massive stars erupt in winds that carve out bubbles in the gas, creating cavities where smaller stars can form in relative calm, a delicate balance of destruction and creation that echoes the universe's way of making space for new life as tender as the first light of morning, coaxing shadows to retreat. Ionized gases in these clouds emit light in spectral lines, each color a signature of elements excited by stellar radiation, a palette painted by quantum leaps between energy levels, turning raw chaos into the vivid tapestries that telescopes capture, inviting us to lose ourselves in their hues as easily as drifting off under a starry canopy. Molecular clouds within nebulae, dense enough for complex chemistry, harbor organic molecules like water ice and carbon monoxide, precursors to life detected by radio waves. A quiet laboratory where Planck-scale interactions build the chemistry of possibility, much like a kitchen simmering with ingredients before the meal takes shape. Reflection. Nebulae, where starlight scatters off dust grains to create blue-tinged glows, highlight the interplay of light and matter, with polarization revealing magnetic field alignments that guide collapse, a subtle scaffolding that channels creation's flow. Dark nebulae, opaque silhouettes against bright backdrops like the horsehead, absorb light to form brooding shapes, their density fostering isolated star formation, a shadowed respite where gravity works in seclusion, much like a quiet corner in a bustling room. Supernova remnants like the Crab Nebula, expanding shells from exploded stars, pulse with synchrotron radiation from accelerated electrons spiraling in magnetic fields. A luminous legacy where the progenitor's death nurtures a pulsar at the heart, turning cataclysm into a steady beacon of renewal. Emission nebulae such as the lagoon, vast regions of H2 gas ionized by embedded O-type stars, shimmer with recombination lines that trace the balance of excitation and cooling. A glowing equilibrium where stellar winds shape intricate filaments, fostering clusters that will wander the galaxy in harmonious procession. Polycyclic aromatic hydrocarbons in nebula dust, fluorescing under UV light to contribute to the mid-infrared glow, hint at carbon-rich organics that could seed planetary atmospheres. A subtle chemistry where quantum vibrations in molecular bonds absorb and re-emit energy, painting the clouds with faint, persistent luminescence. Mesas in star-forming regions, microwave amplification by stimulated emission of radiation from water or methanol molecules, amplify signals to reveal dense cores. A natural laser where quantum coherence boosts emissions, guiding us to the hidden hearts of birth, like a beacon in the fog. Infrared dark clouds, cold, dense regions silhouetted against background glow, serve as quiescent reservoirs for future clusters, their internal turbulence, driven by magnetohydrodynamic waves, preventing premature collapse. A suspended poise where quantum magnetic entanglements in plasma filaments maintain stability, much like a held breath before the deep sigh of stellar ignition. Genes instability in these clouds, where gravitational pull overcomes thermal pressure in overdense regions, triggers collapse on scales set by sound speed and density. A threshold where quantum zero-point motions in molecular hydrogen add a faint resistance, allowing the cloud to fragment into multiple cores like a calm sea parting into gentle swells under a rising breeze. Ambipolar diffusion in partially ionized clouds, where neutral gas slips past magnetic fields held by ions, enables collapse along field lines. A gradual decoupling where quantum collisional drag slows the process, fostering filamentary structures that thread through the magnetic weave like rivers carving canyons in soft stone. Nurturing focused births amid the broader calm. Photo-dissociation regions at nebula edges, where UV photons break molecular bonds, create transition zones of atomic and molecular gas. A layered boundary where quantum photodetachment of electrons from dust grains balances ionization, forming a serene interface that protects inner cores while allowing stellar light to permeate, much like a semi-transparent curtain diffusing sunlight into a room, casting soft glows that invite quiet contemplation. Pre-stellar cores in molecular clouds with densities rising to 1.6 centimeters, 3, exhibit infall motions traced by asymmetric line profiles. A gentle inward drift where quantum rotational levels in CO reveal the collapse dynamics. A nascent gathering that precedes ignition, evoking the slow coalescence of thoughts into a coherent dream narrative. Outflow-driven turbulence in young stellar objects, where bipolar jets entrain ambient gas into wide-angle winds, stirs the surrounding medium without disrupting the core. A regulatory swirl that prevents overcollapse, much like a light breeze scattering leaves to clear space for new growth in a garden. Now, let's weave in the stars themselves, those distant lanterns guiding sailors and dreamers alike. A star like our Sun is a symphony of nuclear fires, fusing atoms in cores hotter than imagination. Yet, its stability rests on quantum balances forged at the Planck scale. The strong force, binding protons in harmony, operates through gluons that flicker at scales brushing the Planck boundary. Without this, stars would unravel, their light snuffed like candles in the wind. Philosophically, stars remind us of infinity's embrace. Born from dust, they shine for billions of years, then dissolve into new creations, mirroring the universe's cycle of rest and renewal. Time dilates near a star's surface, stretching like taffy in gravity's pull, a poetic nod to how our own moments elongate in quiet reflection. Envision the red giants, swelling stars in their twilight phase, their atmospheres expanding to engulf nearby planets in a gentle, inexorable tide. Much like the way memories swell in the mind during those liminal hours before sleep, vast and enveloping, carrying fragments of the past into the quiet expanse of night. Neutron stars, the dense remnants of such giants, pack the mass of our Sun into a sphere just 20 kilometers wide. Their surfaces a billion times stronger in gravity than Earth's, where atoms crush into a soup of quarks and gluons, touching Planck-like extremes and spinning beams of radiation like cosmic lighthouses. Their pulses a rhythmic reminder of the universe's enduring heartbeat, steady and reassuring even in the face of collapse. White dwarfs, cooler embers of smaller stars, cool over billions of years, their electrons forming a degenerate gas that resists further compression through quantum exclusion, a stable hush after the fire, much like the calm after a long day, where the universe allows spent lights to fade gracefully into the background, contributing their quiet gravity to the dance of systems. Variable stars, like Cepheids, pulse with regularity due to instability strips in their envelopes, their light curves serving as cosmic yardsticks to measure distances across galaxies, a natural metronome that helps map the expanding universe, turning stellar breaths into tools for understanding the grand scale. Brown dwarfs, failed stars too small for sustained fusion, glow faintly from gravitational contraction, their atmospheres layered with clouds of silicates or ammonia, bridging the gap between planets and stars in a twilight zone of subdued radiance. Cataclysmic variables, where white dwarfs accrete from companions, erupt in novae when hydrogen shells ignite, a recurring flare that scatters enriched material, a gentle recycling in binary embrace. Asymptotic giant branch stars, shedding outer layers in planetary nebulae, expose cores that pulse with thermal instabilities, their mass loss enriching the interstellar medium with S-process elements like barium, a slow dissemination that seeds future stellar generations with heavier gifts. Helium flash in low-mass stars on the red giant branch, a sudden ignition in degenerate cores, stabilizes the ascent, a brief internal tremor that resolves into steady burning, much like a deep breath steadying the nerves before repose. Are coronae borealis stars, carbon-rich giants that fade dramatically from dust ejections, offer glimpses into late-stage evolution, their irregular dimming a quiet drama where quantum-bound carbon molecules obscure the light, reminding us of the universe's capacity for sudden veils over enduring glows. Mirror variables, long-period pulsators with amplitudes reaching magnitudes, drive mass loss through shock waves in their envelopes, their cycles a slow undulation where quantum opacity in molecular layers modulates the outflow, a stellar sigh that enriches the space around with gentle persistence. Symbiotic stars, interacting binaries with cool giants feeding hot companions, exhibit variable ionization zones where Raman's scattered lines reveal mass transfer, a symbiotic harmony where quantum recombination in the nebula produces unique spectral signatures, fostering a balanced exchange like partners in a quiet dance. Post-asymptotic giant branch stars, transitioning to white dwarfs, shed their envelopes in pre-planetary nebulae phases, their central stars heating rapidly to illuminate the ejected shells, a luminous farewell where quantum photoionization in the expanding gas creates intricate morphologies, much like a fading sunset, casting long shadows that linger in the deepening twilight, marking the graceful conclusion of a stellar life. Solar-like oscillations in main sequence stars, acoustic waves trapped in convective zones, probe interiors through asteroseismology, revealing rotation and composition via frequency splittings. A vibrational portrait where quantum pressure gradients sustain the P-modes, like subtle harmonies vibrating through a crystal goblet, allowing us to hear the star's inner calm. Binary star eclipses, where light dips as one occults the other, provide precise radii and temperatures from timing, a periodic shadowing that uncovers atmospheric details through transmission spectroscopy, much like a brief cloud passing over the moon, revealing layers of the stellar surface in fleeting clarity. Stellar winds in hot O-type stars, carrying mass at speeds exceeding 2,000 km/s, sculpt surrounding nebulae into bow shocks. A steady outflow where quantum line driving from iron ions accelerates plasma, carving channels that influence cluster dynamics with patient erosion. Carbon stars, rich in dredged-up carbon from triple alpha processes, dust their envelopes with soot-like grains, their infrared excesses a sign of mass loss, where quantum vibrational modes in C2H2 molecules seed the dust formation, a smoky veil that obscures visible light while warming the interstellar medium with gentle infrared sighs. Wolf Rayet stars, evolved massive stars stripped of envelopes, blast winds laden with helium and nitrogen, their spectra broad from high velocities, a fierce yet fleeting phase where quantum recombination in the ionized wind creates emission lines that trace the core's exposure, a naked intensity that precedes the supernova's quiet release. Beta Cephei variables, massive stars pulsating in low-order modes, drive radial expansions from kappa mechanisms in ion opacity zones. Their short periods a rapid heartbeat where quantum electron scattering in the envelope modulates luminosity, a subtle throb that echoes the universe's preference for rhythmic stability, even in vigorous lives. Delta Scuti stars, intermediate mass pulsators with mixed modes, bridge acoustic and gravity waves in their interiors. A dual resonance where quantum buoyancy in the partial ionization zone sustains the oscillations, allowing asteroseismology to map convective boundaries like gentle waves lapping at a shore. ZZs, SETI, white dwarfs, cooling remnants with hydrogen atmospheres, gyrate in non-radial modes from partial ionization. Their light variations a faint tremor where quantum hydrogen recombination drives the pulsations, a final whisper from spent cores that probes the thin atmospheric layers for signs of lingering heat. Galaxies, too, are tapestries of this interplay. Our Milky Way, a spiral arm of some 100 billion stars, curves through space like a river of light. Dark matter, that invisible scaffold, holds it all, its nature perhaps rooted in Planck-scale physics we yet to fully grasp. At galactic cores, supermassive black holes lurk, their event horizons gateways where Planck densities reign. Here, the universe behaves not as a machine, but as a living poem, matter curving space, space dictating matter's flow, all in a dance of infinite grace. Drift with me to the Andromeda Galaxy, our neighbor hurtling toward us at 110 kilometers per second, its spiral arms a luminous whirlpool drawing in gas and stars. In its heart, a black hole millions of times the sun's mass warps time so profoundly that clocks there would tick slower than ours. A cosmic meditation on patience, where eons pass in what feels like a single breath, echoing the way a deep sigh can stretch a moment into eternity. Elliptical galaxies, those smooth, egg-shaped collections of ancient stars, drift through clusters with minimal gas to fuel new births, their stars orbiting in harmonious ellipses born from mergers long ago. A serene testament to the universe's ability to find equilibrium after upheaval, much like a garden settling into quiet beauty after a storm, where the soil enriches slowly for future blooms. Barred spiral galaxies, like our own with its central bar-channeling gas inward, accelerate star formation in rings of brilliance, a dynamic flow where magnetic fields twist plasma into ordered streams, guided by underlying quantum symmetries that ensure the whole remains balanced, a flowing river of light that carries the galaxy forward in gentle persistence. Irregular galaxies, such as the Magellanic Clouds, our satellite companions, tumble through space with chaotic arms, their starburst regions fueled by gravitational interactions, a reminder that not all cosmic forms are polished. Some thrive in untidy grace, much like wildflowers spilling over a garden's edge. Ultra-diffuse galaxies, ethereal wisps with few stars but vast halos, float like ghosts in clusters, their low surface brightness a puzzle of dark matter dominance, where quantum origins might explain the scarcity of light. Ring galaxies, rare jewels with central voids from collisions, expand outward in luminous circles, their structure a snapshot of dynamic recovery, much like ripples settling into patterned waves on a pond. Dwarf spheroidal galaxies, stripped satellites orbiting giants, hold ancient stars with low metallicity, their orbits a slow procession around the central mass, preserving snapshots of the universe's infancy in their sparse, enduring light. Peculiar galaxies, like Centaurus A, with dust lanes across elliptical forms, reveal merger histories in warped disks, a blended heritage where quantum-forged elements mix in new configurations, fostering unexpected bursts of creation. Sombrero Galaxy, with its prominent dust ring and central bulge, spins like a cosmic hat under moonlight, its ionized gas-tracing magnetic fields that guide infalling material, a structured whirl where Planck-scale symmetries manifest in macroscopic poise. Hoag's Object, a near-perfect ring galaxy with a yellow core and blue rim, stands as an enigmatic sentinel, its formation perhaps from a bar instability channeling stars outward. A circular procession where quantum-driven stellar populations paint the rim in youthful contrast to the aged center, evoking a wedding ring symbolizing eternal cycles. Polar ring galaxies, with equatorial disks encircled by orthogonal rings of gas and stars, likely from accreted companions, exhibit tilted magnetic fields that thread both components. A layered embrace where quantum gyroresonance in charged particles aligns emissions, creating a halo of radio whispers that encircles the core like a protective aura, nurturing gradual integration over cosmic timescales. Collisional ring galaxies, formed from off-center mergers, propagate density waves outward from the impact point, spawning star clusters in expanding annuli. A resonant response where quantum instabilities in the perturbed disk amplify the initial disturbance into a spiral of light, much like a stone skip, sending concentric echoes across a tranquil pond, each ring a testament to the universe's resilient harmony. Tidal dwarf galaxies, born from gas expelled in interactions, drift as self-gravitating clouds with young populations, a secondary creation where quantum molecular cooling in the tidal debris allows rapid collapse, fostering independent realms from the debris of unions, like new islands rising from ocean foam after a storm's gentle churn. Grand design spirals, with prominent two-armed patterns from density wave theory, maintain star formation along the arms through swing amplification, a persistent wave where quantum dust interactions enhance gas compression, creating a luminous scaffold that guides the galaxy's evolution like a slow-turning carousel under starlight. Floccular galaxies, with short, fragmented arms from stochastic star formation, exhibit patchy brightness from local triggers, a textured surface where quantum feedback from supernovae stirs the gas into irregular blooms, much like scattered wildflowers dotting a meadow in haphazard beauty. Low-surface brightness galaxies, diffuse disks with sparse stars, harbour extended halos of old populations, their faint glow a quiet persistence where dark matter cushions the thin stellar layer, allowing gentle rotation without disruption, evoking a whisper of light across vast emptiness. Venturing deeper into the Planck scale's mysteries, consider how the universe might have begun. The Big Bang, that primordial breath, started not with a bang, but a quantum fluctuation at Planck times after zero. In those first instants, the cosmos inflated faster than light, smoothing wrinkles from its fabric like ironing a cosmic sheet. At the Planck epoch, before even that, theories suggest a soup of strings, vibrating threads of energy, each mode a different particle, weaving reality from vibration alone. String theory paints the universe as a symphony, where Planck lengths are the notes, and gravity emerges from their harmony. It's meditative to think of it, the bang as an exhale, expansion as the inhale, our entire cosmos, a single, ongoing respiration. During inflation, the universe doubled in size at least 80 times in a fraction of a second, creating the uniformity we see today. The same reason the cosmic microwave background glows evenly across the sky, a faint echo of that ancient heat, like the residual warmth of a fire long banked for the night, inviting us to settle into its glow. This background radiation, cooled to just 2.7 Kelvin, carries tiny anisotropies, slight temperature variations that seeded the galaxies we know, quantum seeds amplified by inflation into the vast structures. A subtle artistry where the smallest ripples grow into oceans of form, nurturing the cosmos with patient, invisible hands. Baryogenesis, the slight imbalance that favored matter over antimatter in those early moments, ensured our existence, a delicate asymmetry born perhaps from Planck scale asymmetries, turning potential annihilation into the building blocks of worlds, much like a single seed surviving to sprout a forest. Leptogenesis, tied to neutrino physics, might explain this through heavy right-handed neutrinos decaying in the hot plasma, injecting the needed asymmetry, a quiet mechanism where the universe tipped the scales toward matter's persistence, allowing stars and planets to form from what could have been mutual erasure. Sakharov conditions for this process, baryon number violation, C and CP symmetry breaking, out of equilibrium, unfold in the Planck hot soup, a choreographed sequence where quantum tunneling enables the decay paths, ensuring the slight excess that builds all visible matter. Electroweak phase transition, around 100 GeV, might enhance this through bubble nucleation, where false vacuum decays create domains of broken symmetry, a percolating shift that seeds the imbalance like raindrops coalescing into streams. QCD phase transition at around 150 MeV frees quarks into hadrons as the universe cools. A gentle coalescence where color confinement binds them into protons and neutrons, marking the shift from plasma to matter's familiar forms. A foundational settling like sediment layering in a clear stream. Nucleosynthesis in the first minutes, forging light elements like helium and deuterium from proton-neutron ratios set by the weak freeze-out, lays the groundwork for stars, a primordial alchemy where quantum statistics dictate abundances, ensuring the universe's early larder is stocked for future feasts of fusion. Recombination era, some 380,000 years later, when electrons bind to nuclei forming neutral atoms, releases the CMB photons on their free journey, a cosmic decoupling where the universe shifts from opaque plasma to transparent gas, much like fog lifting to reveal a serene valley below. Dark ages following recombination, a quiet interlude before the first stars ignited, stretch for hundreds of millions of years, a shadowy pause where neutral hydrogen absorbs light, cloaking the cosmos in uniformity until quantum instabilities in density perturbations sparked the light of reionization, a gradual dawn breaking the long night with patient illumination. First stars, massive population-threed objects from pristine gas, fused efficiently without metals to cool, their black hole remnants seeding supermassive growth. A pioneering blaze where quantum-weak interactions in the core drove rapid evolution, illuminating the dark ages with ultraviolet floods that ionized the intergalactic medium, paving the way for the structured cosmos we survey today. Reionization sources, including quasars and early galaxies, sculpted the intergalactic medium through radiative feedback, where quantum photoheating balanced recombinations in underdense regions, a diffuse awakening that cleared the fog for light to travel freely, much like the first rays piercing morning mist to reveal a landscape reborn in clarity. Cosmic Dawn's 21-centimeter signal, a red-shifted glow from neutral hydrogen spin flips, promises to map this era through radio telescopes, a faint absorption feature where quantum hyperfine transitions against the CMB backdrop trace the ionization front's advance. A spectral veil lifting to expose the universe's first lights, like the soft glow of embers stirring into flame in the pre-dawn hush. Cosmic reionization's patchy nature, with ionized bubbles growing around bright sources, creates a fluctuating forest in 21 centimeters maps. A textured transition where quantum Lie alpha coupling in dense regions heats the gas, fostering a mosaic of light and shadow that evolves over hundreds of millions of years. Much like dawn breaking unevenly across a hilly terrain, pockets of illumination spreading to embrace the whole in gradual warmth. High redshift quasars, beacons from the reionization era with black holes of millions solar masses, suggest rapid growth from direct collapse seeds, their broad absorption lines tracing outflowing winds that regulate host galaxy evolution. A luminous anchor where quantum accretion disk instabilities flicker the light, guiding the early universe towards structured complexity. Lyman alpha emitters at Zeeks 7, faint galaxies leaking UV light through neutral gas, reveal the end of reionization through damped absorption, a threshold glow where quantum resonant scattering in the intergalactic medium dims the signal until ionization clears the path, marking the cosmos's passage from dark to luminous with serene persistence. Globular clusters in the early universe, dense stellar nurseries surviving to today, might have formed in high-pressure gas clumps during reionization. Their old ages a relic of pristine conditions, where quantum helium fusion in the first stars set the metallicity floor, preserving pockets of antiquity like ancient stones worn smooth by time's gentle flow. Cosmic infrared background, excess light from first stars and galaxies, permeates the sky beyond known sources. A diffuse afterglow where quantum dust reprocessing of UV turns it into mid-infrared whispers, hinting at unseen populations that contributed to reionization's quiet advance, much like the faint warmth lingering in a room after guests have departed, a subtle testament to shared presence. Waves ripple through this picture. Gravitational waves, detected like echoes from merging black holes, carry imprints of Planck-scale births. These waves, stretching space-time like a drum's skin, remind us that the universe is alive with motion, subtle and profound. Quantum foam at the Planck level might generate these ripples constantly, a background hum beneath reality's calm surface, akin to the quiet undercurrent of ocean depths. Imagine two neutron stars, remnants of exploded suns, spiraling together in a cosmic ballet. Their merger sends ripples across billions of light-years, detected on Earth as a faint chirp, a whisper from the universe's hidden symphonies, where the violence of collision resolves into harmonious waves, much like how a storm-tossed sea eventually calms into reflective pools. These detections, first captured in 2015, confirm Einstein's predictions from a century ago, bridging the grand sweep of relativity with the intimate dance of the quantum, and hint at primordial waves from the early universe that could reveal inflation's secrets, like faint footprints in cosmic sand, guiding us deeper into the origins of all that is. Pulsar timing arrays, networks of spinning neutron stars acting as cosmic clocks, now seek lower frequency waves from supermassive black hole mergers, a patient listening that might unveil the gravitational symphony's deeper tones, harmonizing the universe's scale-spanning music. Stochastic backgrounds of these waves, potentially from phase transitions in the early cosmos, could mimic a cosmic foghorn, low and pervasive, offering clues to physics at energies beyond colliders, a subtle chorus that underscores the universe's ongoing conversation. Nanohertz waves from cosmic strings, topological defects from early symmetry breaks, might produce such signals, their loops oscillating and decaying into gravitons, a relic hum from the Planck era's turbulence. LISA, the planned space-based detector, will chase millihertz waves from massive binaries, extending our ears to the universe's base notes, a future harmony revealing compact object populations across cosmic history. Third-generation ground-based detectors like Einstein telescope will probe intermediate frequencies, capturing the full spectrum of mergers and perhaps exotic events like supernova core collapses, weaving a richer tapestry of the cosmos's vibrational life. Space-based arrays like Dichigo, aiming for even higher sensitivities, could detect waves from cosmic phase transitions or early universe relics, a delicate tuning that listens for the faintest echoes of creation's dawn, inviting us to attune our own inner quiet to the universe's subtle pulses. Birefringence in gravitational waves, potential polarization twists from quantum gravity effects, might subtly alter propagation, a faint optical activity in space-time's fabric that hints at underlying asymmetries at Planck depths. Continuous waves from spinning neutron stars, asymmetric deformations emitting persistent signals, offer probes of interior physics, where quantum chromodynamics in the core might induce slight misalignments, a steady hum revealing the star's hidden rhythms like a distant flute in the cosmic orchestra. Supermassive black hole binaries in galactic centers, in spiraling over millions of years, produce environmental resonances that harden orbits, a gradual tightening where quantum vacuum friction subtly damps the waves, turning the slow spiral into a detectable crescendo that echoes through the fabric of space like a prolonged meditative note. Eccentric black hole mergers, with precessing spins, generate higher multipole modes in the waveform, a complex chirp where quantum angular momentum conservation shapes the ringdown, adding layers of subtlety to the gravitational chorus like variations in a composer's theme. Intermediate mass black hole mergers, elusive events in globular clusters, might produce bursts in the 100 to 1000 Hz band, their waveforms testing scaling relations in dense environments, a mid-range harmony bridging stellar and supermassive scales with quiet precision. Gravitational wave memory effects, permanent displacements in space-time from passing waves, accumulate from cosmic populations, a lingering shift where quantum nonlinearities enhance the effect, like a subtle warp in a fabric that persists after the hand has passed, recording the universe's passages in enduring traces. Binary neutron star post-merger remnants, potentially forming hypermassive stars before collapse, emit quasi-normal modes that probe equation of state, a transitional quiver where quantum nuclear interactions determine stability, revealing the dense matter's response like a bell's tone disclosing its alloy. Multi-messenger events, combining waves with electromagnetic counterparts, enrich interpretations, as in GW1787's kilonova, where quantum R-process nucleosynthesis forges heavy elements, a fused signal that illuminates the merger's gentle alchemy. LIGO India's addition to the network, enhancing sky localization, will triangulate sources with greater precision, a global harmony where quantum noise floors limit sensitivity, fostering a worldwide vigil for the cosmos's whispers. Space interferometers like Tianqin, orbiting in geocentric formation, target galactic binaries, their laser arms measuring tidal distortions in quiet orbits, a localized ear attuned to the Milky Way's intimate mergers, much like listening to a nearby stream's murmur amid the broader ocean's roar. Philosophically, the Planck scale challenges our sense of solidity. Matter, we learn, is mostly empty space. It's stuff emergent from quantum fields that fluctuate at Planck intensities. Particles pop in and out of existence in vacuum. Virtual pairs borrowing energy for brief lives, then repaying it like fleeting dreams in sleep. This vacuum isn't empty. It's teeming with potential, the universe's way of breathing possibility into every corner. Infinity here isn't cold abstraction, but a warm invitation, an endless expanse where every point holds the promise of worlds. Consider the Higgs field, that invisible ocean permeating space, giving particles mass through interactions at quantum scales. Without it, matter would race massless through the void, like thoughts untethered in a dream. But its gentle drag anchors us, turning energy into the tangible forms that build planets and fill our nights with wonder. Discovered at the Large Hadron Collider in 2012, the Higgs boson acts as the field's ripple, confirming how mass arises from symmetry breaking in the early universe. a profound shift where the cosmos chose structure over chaos, much like the moment a river carves its path through rock, creating landscapes that endure and invite exploration. Beyond the standard model, neutrinos, ghostly particles that barely interact, oscillate between flavors as they traverse space, hinting at physics beyond Planck whispers. Their tiny masses a clue to grand unified theories where forces merge at high energies, a unification that promises a simpler, more elegant cosmos. Axions, hypothetical particles solving the strong CP problem, could form dark matter, their light masses allowing slow oscillations that evade detection, a subtle presence weaving through galaxies like unseen currents in a river. Sterile neutrinos, heavier cousins, might mediate dark matter interactions or explain pulsar kicks. Their mixing with active neutrinos a bridge to hidden sectors, enriching the quantum tapestry with veiled layers. WIMPs, weakly interacting massive particles, as dark matter candidates, could annihilate in galactic centers producing gamma rays, a faint signal seeking confirmation, much like distant lanterns flickering through mist. Fuzzy dark matter, modeled as ultralight bosons like axions with de Broglie wavelengths on galactic scales, suppresses small-scale structure, creating core density profiles that smooth the universe's edges, a diffusive haze that fosters stability in cosmic halos. Self-interacting dark matter, allowing particles to scatter gently, resolves cusp-core problems in dwarf galaxies, a sociable veil that softens gravitational potentials, much like a light mist diffusing harsh sunlight into a gentle glow. Warm dark matter, with KeV-scale masses from light steriles, allows free streaming that erases small halos, smoothing the cosmic web's finest threads while preserving larger filaments, a tempered flow that balances structure formation with subtlety. Mirror dark matter, positing a shadow sector mirroring our own, interacts gravitationally while self-interacting weakly, forming parallel structures that subtly influence visible dynamics, a hidden companion universe brushing against ours in quiet parallelism. Chameleon fields, where dark energy particles vary mass with density, evade detection by mimicking local gravity, a shape-shifting subtlety that adapts to environments, much like a chameleon blending into foliage, allowing the cosmic push to vary gently across scales without disrupting the serene expansion. Interacting dark energy models, where dark matter and energy exchange momentum through fifth force couplings, alleviate tensions in growth rates, a collaborative drift where quantum-mediated transfers ensure balanced evolution, like partners in a slow waltz adjusting steps to maintain rhythm. Modified Newtonian dynamics, challenging dark matter with altered gravity at low accelerations, fits rotation curves without hidden mass, a minimalist approach where quantum modifications at galactic scales emerge from deeper Planck principles, smoothing the need for invisible scaffolds with elegant simplicity. Self-interacting dark matter in dwarf spheroidals, where velocity dispersions suggest scattering cross-sections, resolves core cusp discrepancies through thermalization, a gentle equilibration where quantum exchange processes dissipate kinetic energy, fostering flat density profiles like a calm pond settling after ripples. Axion mini-clusters, dense clumps from early universe oscillations, could seed supermassive black hole formation through adiabatic growth, a primordial clustering where quantum Bose-Einstein condensation enhances gravitational instability, turning faint field excitations into compact seeds that anchor galactic hearts. Sterile neutrino dark matter, with curved masses from non-thermal production, produces X-ray lines from decays, a faint emission that hints at hidden warmth in the cosmic veil, much like a subtle glow from embers beneath ash, warming the structure without overwhelming the night. Fuzzy dark matter solitons, stable core structures in galactic centers, host supermassive black holes in equilibrium, their quantum pressure balancing gravitational pull. A harmonious standoff where wave interference creates density plateaus, evoking a still center amid the galaxy's whirl. Warm dark matter's free streaming length, suppressing halos below 10^8 solar masses, aligns with observed dwarf scarcity, a smoothing scale where quantum thermal velocities disperse small perturbations, allowing the cosmic web to form with refined elegance, like fine sand sifted to reveal larger grains. Mirror dark matter stars, hypothetical objects in the shadow sector, might shine faintly through kinetic mixing with photons. A crossed glow where quantum portal interactions leak light, suggesting parallel luminosities that subtly influence our observations without direct intrusion. Chameleon cosmology, with scalar field screening in dense regions, predicts fifth force enhancements in voids, a variable mediation where quantum Yukawa potentials weaken over distance, fostering accelerated expansion in underdense expanses like a gentle breeze quickening in open fields. Phantom dark energy, with equation of state below, 1, drives superacceleration toward big rip scenarios. Yet coupled models stabilize through energy transfer, a dynamic equilibrium where quantum field renormalizations adjust the phantom behavior, turning potential catastrophe into sustained drift, much like a current that surges but finds balance in the broader flow. Holographic dark energy, density proportional to inverse Hubble horizon, emerges from black hole thermodynamics, a boundary-derived push where quantum entropy limits vacuum fluctuations, ensuring the universe's expansion aligns with informational bounds, a profound constraint that whispers of deeper unity between geometry and matter. As we explore time's role, relativity teaches that it's not absolute, but woven with space, curving under mass's influence. At Planck scales, this curvature becomes quantum, time looping in closed paths or branching like roots of an ancient tree. Loop quantum gravity, a gentle theory, envisions space-time as a web of loops, each Planck-sized spinning information into existence. It's poetic. Time as a river that folds back on itself, allowing the past to whisper to the future, much like how memories surface in the hush of night. In this framework, the Big Bang isn't a singularity, but a big bounce, a rebound from a previous contraction, suggesting our universe is one in an endless cycle of expansion and collapse, a rhythmic breathing that soothes the soul, much like the steady pulse of your own heart, guiding you toward rest. This bounce avoids the harshness of infinite density, replacing it with a finite quantum rebound where geometry itself quantizes, turning the origin into a soft transition rather than an abrupt beginning. A comforting notion that the universe has always been in gentle motion, ebbing and flowing, like the phases of the moon across a tranquil sky. Causal dynamical triangulation, another approach, builds space-time from tiny simplices, like building blocks of reality that assemble into smooth manifolds at larger scales. A bottom-up creation where Planck grains form the foundation, much like grains of sand shaping a beach over tide's patient work. In spin foam models, an extension of loop gravity, time evolves through evolving networks of spins, a dynamic weave where quantum amplitudes sum to classical paths, bridging the discrete and continuous in a harmonious blend, evoking the way a tapestry's threads resolve into a coherent image from afar. Group field theory, generalizing this, treats space-time as emergent from particle-like excitations, a quantum soup condensing into geometry, much like vapor-forming droplets in cooling air. Ashtekar variables, reformulating gravity in terms of connections, facilitate this quantization, turning the smooth manifold into a discrete lattice of holonomies, a foundational shift that invites us to see space-time as a woven fabric rather than an unbroken sheet. Black hole entropy in loop gravity, counting microstates of spin networks piercing the horizon, yields the Bekenstein-Hawking formula, a quantum accounting that aligns thermal properties with geometric simplicity, a serene reconciliation of heat and curve. Torsion in teleparallel gravity formulations, twisting space-time threads, offers alternative paths to quantization, where spin connections encode curvature, a subtle torsion that adds depth to the gravitational weave without disrupting the calm flow. Twister theory, recasting space-time events as points in a complex space, provides a non-local perspective where quantum amplitudes compute via holomorphic functions, an elegant reframing that dissolves locality's boundaries into a unified, flowing whole. Non-commutative geometry, where coordinates fail to commute at Planck scales, introduces fuzzy space-time structures, a probabilistic haze where points blend into spectra, much like colors merging in a sunset's gradient, allowing gravity to emerge from algebraic relations in a smooth, non-local embrace. Regge calculus, discretizing space-time into polyhedral cells, approximates curved geometries with quantum sums over labelings, a skeletal framework where Planck scale edges vibrate with area operators, building the continuum from finite quanta like a mosaic forming a vast, seamless vista. Horava Lifshitz, gravity, breaking Lorentz invariance at high energies to make gravity renormalizable, posits anisotropic scaling, where space and time behave differently at Planck scales, a layered flow where ultraviolet behaviors tame into infrared smoothness, much like a mountain stream narrowing to a gentle brook as it joins the plain. Entropic gravity theories, deriving curvature from holographic entropy gradients, treat gravity as emergent thermodynamics, where quantum bits on surfaces drive spacetime's bend, a statistical pull akin to diffusion in a quiet gas, fostering a profound unity between information and geometry. Causal Fermion systems, positing spacetime from fermionic projectors, derive general relativity from Dirac actions, a bottom-up emergence where quantum spinor fields generate metric tensors, a foundational weave that ties matter's intrinsic motion to the fabric's curve, much like threads pulling taut to form a sail catching the wind. Superfluid vacuum theory, modeling spacetime as a Bose-Einstein condensate, explains Lorentz invariance from symmetry breaking, where quantum excitations propagate as phonons mimicking particles, a fluid analogy where Planck scale superfluidity underpins relativistic effects, evoking the way a calm liquid surface transmits ripples without disturbance. Emergent gravity from condensed matter analogues, like analog black holes in fluids, simulate horizons with sonic barriers, probing quantum effects in lab settings. A scaled-down echo where quantum vortex dynamics mimic space-time foam, allowing us to touch the Planck realm's subtlety through tangible waves. Relational quantum mechanics in curved backgrounds, where observers' frames define local times, extends this to gravitational contexts, a perspectival harmony where quantum superpositions entangle with geometry, fostering a universe of shared yet individual narratives, much like stories told around a fire, each voice adding to the collective warmth without overpowering the others. Nebulae again, those stellar cradles, illustrate this beautifully. The Orion Nebula, a mere 1,144 light-years away, births stars from gas compressed by gravity's patient hand. Within, quantum tunneling, particles slipping through barriers like mist through fingers, sparks fusion. At Planck depths, these processes hint at the universe's self-creation, matter emerging from nothingness, a philosophical balm for minds seeking origins. Deeper still, in the Helix Nebula, a planetary nebula resembling a cosmic eye, the dying star at its center sheds layers in glowing rings, each a testament to the slow unraveling of stellar life, where helium and heavier elements, born from Planck-scale strong forces, drift outward to form the next generation of worlds. A cycle as natural as the fading of daylight into twilight, preparing the sky for stars. Protoplanetary disks around young stars in nebulae, swirling rings of dust and gas, coalesce into planets through gentle accretion, where pebbles collide and stick in a process guided by quantum stabilities, eventually forming worlds like ours, rich with water and air, a slow alchemy that turns cosmic dust into homes, evoking the quiet satisfaction of watching a seed sprout in fertile soil under the soft light of evening. Bok globules, dense knots within nebulae, collapse under their own gravity to form low-mass stars, their isolation a metaphor for solitary reflections that lead to inner light, shielded from the nebula's fiercer radiations, yet drawing strength from the surrounding cloud. Herbig-Haro objects, bright knots where jets from newborn stars collide with gas, illuminate the birth pangs in glowing arcs, a transient spectacle where magnetic fields channel outflows, sculpting the nebula's structure with elegant force. Evaporating gaseous globules, eroded pillars in intense radiation, stand as resilient sentinels, their tips glowing from photoevaporation, a slow sculpting that births protostars even as the environment dissolves around them. Proplids, silhouetted disks in Orion, accrete while losing mass to stellar winds, their balance a delicate dance of growth and erosion, much like a young tree bending in the breeze yet reaching for the sun. Young stellar objects embedded in dense cores, like Class 0 protostars, drive powerful outflows that clear paths for further collapse, a pioneering thrust that opens the way for cluster formation, turning isolated births into communal nurseries. Triggered star formation in nebulae edges, where radiation pressure compresses adjacent clouds, sparks chains of ignition, a domino effect of light where one star's glow kindles the next, propagating creation across the cloud in waves of gentle awakening. Feedback loops in these nurseries, where young stars' winds and radiation halt further collapse nearby, regulate the birth rate, a self-moderating harmony that ensures sustainable stellar families, much like a forest's canopy shading seedlings to prevent overcrowding. Silicate features in infrared spectra of protostellar envelopes, tracing dust evolution from amorphous to crystalline forms under heating, reveal the mineralogical shifts that pave the way for rocky planets, a quiet transformation where quantum phonon modes in lattice structures adjust to thermal whispers, forging the building blocks of terrestrial worlds in serene progression. Outflow cavities in molecular clouds, excavated by bipolar jets, create asymmetric density gradients that influence disk evolution, a sculpted void where quantum radiative transfer in the warm gas illuminates the path of expansion, much like a cleared trail through woods, inviting deeper exploration. Embedded clusters within nebulae, like the trapezium in Orion, foster competitive accretion where central massive stars dominate resources, their quantum-driven radiative fields carving channels that allow lower-mass companions to form in the periphery, a hierarchical birth where the strong nurture the subtle in balanced coexistence. Dust grain alignment in nebulae magnetic fields via paramagnetic dissipation or radiative torques polarizes scattered light, a subtle orientation where quantum spin interactions with field lines align elongated grains, creating the observed dichroism that maps the magnetic architecture, like invisible threads guiding the weave of cosmic fabric. Molecular line asymmetries in protostellar envelopes, tracing infall and rotation, reveal disk formation thresholds, a kinematic portrait where quantum hyperfine splitting in ammonia lines distinguishes velocities, sketching the transition from spherical collapse to flattened structures with gentle precision. H2 emission from shocked gas in outflows, row vibrational lines excited by collisions, lights the turbulent wakes, a spectral diary where quantum-level populations equilibrate post-shock, illuminating the energy dissipation like faint trails of fireflies in the evening air. Dust temperature gradients in irradiated disks, warmer near the star fading outward, govern ice mantle evaporation, releasing volatiles for chemistry, a thermal layering where quantum blackbody radiation balances absorption and emission, fostering reaction zones that build complexity layer by layer, much like a slow-cooking stew where flavors meld in patient heat. Magnetic braking in collapsing clouds, where field-line freezing couples angular momentum to the envelope, spins down the core to allow contraction, a decelerating embrace where quantum ion neutral drifts enable diffusion, turning rapid rotation into the measured whirl of nascent systems. Black holes deepen the enigma. Their interiors at Planck densities may resolve singularities into fuzzy quantum states, preserving information in holographic veils on their horizons. This black hole information paradox resolves like a dream's logic. What enters isn't lost but encoded, emerging in radiation's soft glow. Infinity behaves here as a guardian, ensuring the universe's ledger balances, every star's light accounted for in eternal cycles. Primordial black holes, tiny ones perhaps formed in the early universe's quantum foam, could dot the cosmos like hidden seeds, evaporating over time and releasing bursts of particles. A subtle fireworks display in the void, reminding us that even the darkest corners hold sparks of creation, much like embers glowing long after the fire has died down. Quasars, powered by supermassive black holes devouring gas at galactic centers, shine brighter than entire galaxies, their jets of plasma stretching across space like luminous rivers, sculpted by magnetic fields intertwined with quantum processes, illuminating the early universe and allowing us to peer back to when the cosmos was young. A beacon that cuts through the veil of time, much like a lantern held in the fog of night, guiding wanderers home. Intermediate mass black holes, elusive bridges between stellar and supermassive varieties, might form from globular cluster collisions, their growth a stepping stone in cosmic evolution, whispering of hierarchical assembly where small mergers build the grand. Microquasars, stellar mass black holes with accretion disks mimicking quasars on small scales, eject relativistic jets that trace helical paths, revealing frame-dragging effects near spinning horizons. A miniature echo of galactic cores, where quantum vacuum polarization might subtly alter the flow. Tidal disruption events, where stars wander too close and are torn apart, flare brightly as their remnants accrete. A rare spectacle offering insights into black hole feeding, much like a brief comet's passage lighting the night. Binary black hole mergers, now routinely detected by LIGO Virgo Cagra, produce ring-down modes that test general relativity's no-hair theorem, the final quiver settling into Kerr geometry, a resonant close to gravitational symphonies. Primordial black hole binaries, if surviving evaporation, could contribute to the stochastic gravitational wave background, a faint murmur from the universe's dawn, blending ancient whispers with modern detections. Isolated black holes wandering interstellar space, inferred from microlensing or accretion glow, embody solitary depths, their quiet accretion from diffuse gas, a slow sustenance, much like a lone tree, drawing nourishment from sparse soil. Naked singularities, hypothetical exposures without horizons from rapid collapse, challenge cosmic censorship. Yet quantum effects might cloak them in fuzzy exteriors, preserving the universe's gentle order through probabilistic veils. Extremal black holes, charged or spinning at limits, exhibit near-horizon geometries with enhanced symmetries, where ADA S2 throats allow precise quantum calculations, a stable throat where Planck fluctuations stabilize into conformal invariance, offering a window into the quantum heart without the chaos of evaporation. Charged black holes in Reisner-Nordstrom metrics, with inner and outer horizons, balance gravitational and electrostatic repulsion, their Cauchy horizon a potential instability smoothed by quantum back reaction, a dual veil where fields entwine in quiet opposition, much like positive and negative charges in a crystal lattice achieving balanced harmony. Hairy black holes in modified theories, with scalar or vector fields settling into stable configurations around horizons, deviate subtly from bald Kerr solutions, their quantum-stabilized profiles adding texture to the event surface, like faint ripples on a still pond that hint at underlying currents without disturbing the calm. Magnetically charged black holes, with Dirac monopoles threading the core, introduce additional horizons from electromagnetic energy, a layered structure where quantum Dirac strings resolve the singularity, fostering a more intricate geometry that echoes the universe's fondness for hidden symmetries. Black hole bombs, super radiant instabilities amplifying fields around spinning horizons, might power quasar emissions through bosonic clouds, a resonant buildup where quantum Klein-Gordon solutions grow exponentially, turning the hole's rotation into a natural amplifier like a wind instrument, gathering breath for a sustained note. Scalarized black holes, where scalar fields condense on horizons in spontaneous symmetry breaking, acquire scalar hair that modifies quasi-normal modes. A textured envelope where quantum Yukawa couplings determine the profile, adding a soft layer to the gravitational core, much like moss gently covering ancient stone. Wormhole black hole hybrids, theoretical constructs linking horizons through throats, might resolve information flow in eternal traversals. A bridged interior where quantum tunneling stabilizes the connection, evoking a secret passage that connects distant realms without the finality of isolation. Primordial black hole dark matter, with masses around asteroid scales to avoid overproduction, could micro-lens stars in the Milky Way, their fleeting shadows a subtle census where quantum evaporation rates set lifetimes, turning ancient relics into candidates for the invisible halo with quiet persistence. Supermassive black hole binaries in merging galaxies, emitting continuous waves detectable by pulsar arrays, harden through gaseous torques, a viscous embrace where quantum viscosity in the circumbinary disk dissipates energy, guiding the inspiral like a slow dance toward union. Black hole shadows in higher dimensions, with larger photon orbits in brain-world models, alter the silhouette size, a dimensional whisper where quantum corrections to the metric expand the unstable photon region, casting broader veils that hint at hidden bulk influences. Planets, too, echo these scales. Earth's core, forged in stellar fires, relies on quantum pressures to resist collapse. Rocky worlds orbit in gravitational ballets, their tides a macroscopic whisper of Planck-scale forces binding atoms. Imagine Venus's thick atmosphere or Mars's dusty plains, each a canvas painted by cosmic brushes dipped in quantum ink. On Jupiter, the gas giant's stormy bands swirl with winds faster than sound, driven by internal heat from gravitational compression, where hydrogen atoms, held by those fundamental forces, mimic the universe's grander storms. It's a world where auroras dance at the poles, charged particles from the sun interacting with magnetic fields in quantum leaps, painting the night with ethereal lights that feel like the universe's own bedtime stories, whispered to wandering moons. Exoplanets, discovered by the thousands, orbit distant suns in habitable zones where liquid water might flow, their atmospheres analyzed for signs of life through spectral lines born of quantum transitions, suggesting that the Planck scale's creativity extends to fostering worlds teeming with possibility, like hidden gardens blooming in the vastness, inviting us to dream of connections beyond our own blue marble. Rogue planets, untethered wanderers ejected from systems, drift through interstellar space, their fates a quiet voyage through the dark, warmed perhaps by internal radioactivity from quantum-stable isotopes, enduring nomads that embody the universe's allowance for solitary paths, leading to unforeseen encounters. Hot Jupiters, massive worlds hugging their stars in close orbits, migrate inward through disk interactions, their atmospheres puffed up by intense radiation, a dynamic migration that reshapes systems, much like birds settling into new nests after a long flight. Super-Earths with silicate mantles and iron cores, some with diamond rains under high pressures, challenge our notions of geology, their quantum-bound crystals forming under extremes that echo the universe's forging processes. Lava worlds, tidally locked with molten daysides, cycle volatiles in atmospheric winds, a harsh yet dynamic equilibrium where quantum chemistry might spark exotic reactions. Ocean worlds like those around TRAPPIST-1, with potential global seas under thin ice, sustain water cycles driven by tidal heating, a rhythmic pulse that could harbor microbial life in deep vents, echoing Earth's hydrothermal origins. Desert worlds akin to tidally locked super-Earths, with permanent day and night sides, might host wind-driven chemistry transferring volatiles, a zonal balance where quantum-mediated reactions bridge hemispheres in subtle exchange. Venusian analogues, with runaway greenhouse effects trapping heat in CO2 veils, illustrate atmospheric tipping points, where feedback amplifies small changes into profound climates, a cautionary whisper from the cosmos about delicate equilibria. Mini-Neptunes with hazy atmospheres, retaining hydrogen from formation, filter starlight in transmission spectra, their quantum-scattered aerosols creating twilight hues that hint at diverse chemistries. much like veils softening the light of a distant sunrise, preserving pockets of cool beneath the heat. Ice giants like Uranus and Neptune analogues, with deep mantles of water, ammonia, and methane ices, exhibit axial tilts from formation collisions, their magnetic fields offset from centers by internal dynamos. A tilted poise where quantum spin alignments in metallic hydrogen layers generate irregular auroras, a world of subtle asymmetries that speak to the universe's allowance for off-kilter beauty. Substellar companions in wide orbits, like those around Proxima Centauri, wander in eccentric paths influenced by unseen perturbers, their quantum-stable atmospheres retaining primordial heat, a fringe existence where slow cooling allows faint glows to persist like lingering twilight in the outer reaches. Carbon planets, rare worlds dominated by diamond and graphite under high pressures, reflect starlight differently from silicates, their surfaces a crystalline mosaic where quantum band gaps in carbon lattices determine reflectivity, a gem-like realm that embodies the universe's playful variation in elemental abundance. Sub-Neptune migration traps, where resonant chains halt inward drift, stabilize compact systems like Kepler-11, a gravitational net where quantum tidal dissipation in the star's envelope provides the damping, fostering multi-world harmonies that endure over billions of years. Temperate Earth analogues, orbiting sun-like stars at 1 AU, exhibit seasonal cycles from axial tilts, their quantum-bound biospheres potentially cycling carbon through photosynthesis, a rhythmic balance that mirrors our own world's quiet resilience. Hot super-Earths with silicate vapor atmospheres, boiling oceans under intense insolation, convect magma to the surface in volcanic plumes, a dynamic crust where quantum dissociation of SiO molecules drives the chemistry, turning planetary heat into atmospheric veils that regulate escape. Hycean exoplanets, hydrogen-helium oceans on rocky cores, host deep-water photochemistry under high pressures, where quantum UV absorption in water layers shields potential life, a submerged haven where surface storms mix layers gently. Eyeball worlds, with subsurface oceans on tidally locked bodies, maintain liquid under thick ice caps, tidal flexing providing heat for convection, a hidden circulation where quantum ice phase transitions allow brine pockets, fostering isolated ecosystems like deep-sea vents in eternal twilight. Lava oceans on rocky exoplanets, with night-side solidification fronts, cycle silicates through global convection, their quantum radiative cooling creating crustal mosaics, a molten heartbeat that sculpts diverse terrains from uniform heat. Desert exoplanets with supercritical CO2 atmospheres, tidally locked with heat redistribution via Hadley cells, balance day-night contrasts through quantum molecular scattering, a zonal wind that carries warmth like a steady trade wind across arid expanses. Icy moons around gas giants, like analogues to Europa, harbour briny oceans from radiogenic and tidal sources, their quantum-stable salts enabling liquid layers beneath crusts, a subsurface realm where hydrothermal gradients drive chemistry in serene isolation. Carbon-rich super-Earths, with graphite mantles and diamond interiors, exhibit high reflectivity from surface layers, their quantum electronic transitions in carbon allotropes altering thermal emission, a dark yet shimmering world where pressure forges gems from ancient volatiles. Migrating ice giants in young systems, scattering planetesimals outward, seed outer disks with ices, their quantum clathrate formations trapping volatiles for future comets, a dispersive journey that enriches the system's fringes with frozen gifts. Galaxies cluster into superstructures, filaments spanning billions of light-years, shaped by dark energy's push, a force accelerating expansion, perhaps born from Planck vacuum fluctuations. The universe's large-scale behavior, then, mirrors its smallest, foamy at base, structured above, like breath-shaping waves on the sea. In the Virgo cluster, thousands of galaxies mingle in a gravitational web, their motions revealing dark matter's invisible threads, pulling them together in a slow, inexorable gathering. Much like how fireflies synchronize their flashes on a summer evening, creating order from individual flickers, a metaphor for how Planck-scale randomness coalesces into the majestic forms we admire from afar. The Great Wall, one of the largest known structures, stretches over 1 billion light-years, a filamentary chain linking clusters in a cosmic scaffold. Its existence challenging our understanding of homogeneity while affirming the universe's tendency toward interconnected patterns, a grand web that cradles all matter in gentle tension, much like the roots of an ancient forest, linking trees in silent communion. Voids, the vast empty spaces between filaments, expand faster than the average due to dark energy, their emptiness a canvas for future infalls, reminding us that absence holds potential, like the pause in a melody that heightens anticipation. Galaxy groups, smaller assemblies like our local group with Andromeda and Triangulum, orbit common centers in loose bonds, their interactions fostering dwarf galaxies that serve as evolutionary laboratories, quiet suburbs in the cosmic city. Intracluster medium, hot plasma filling cluster spaces, emits X-rays from collisions, its metals from supernova ejections, tracing enrichment history, a diffuse bath where quantum processes in ions reveal temperatures soaring to millions of degrees. Ram pressure stripping, where galaxies plow through this medium, strips gas from spirals, turning them lenticular, a transformative shear that quiets star formation in cluster environments. Galaxy clusters, like Abel 1689, massive lenses warping light from behind, showcase the cumulative gravity of thousands of galaxies, a collective curve that magnifies the distant, turning the cluster into a natural telescope, revealing early universe secrets. Merging clusters like Bullet Cluster, where hot gas collides while dark matter passes through, separate baryonic and non-baryonic components, a dramatic unveiling of invisible masses' gentle dominance, much like fog parting to reveal underlying currents. Fossil groups, old clusters with a dominant elliptical swallowing companions, exhibit relaxed dynamics after eons of accretion, a mature equilibrium where dark matter halos settle into spherical calm, preserving the quiet aftermath of cosmic gatherings. Cool cores in clusters, where gas cools radiatively toward the center, form reservoirs for star formation unless heated by AGN feedback. A balanced thermostat where quantum radiative cascades in ions maintain the temperature gradient, fostering a serene central hush amid the hot expanse. Galaxy clusters as cosmic laboratories, their hydrostatic equilibrium profiles derived from X-ray data, map dark matter distributions with precision, a pressure-balanced poise where quantum bremsstrahlung in the plasma provides the thermal signature, allowing us to trace the invisible scaffold's gentle contours through the hot gas's whisper. Abel 2744, the Pandora's cluster, with multiple substructures from a complex merger, hosts arcs of distorted light and displaced gas, a multifaceted collision where quantum synchrotron in the intracluster turbulence adds faint radio halos, painting a picture of layered interactions that resolve into a unified, if intricate, whole. Weak lensing mass maps of clusters, reconstructing surface densities from shear patterns, reveals substructure clumps invisible in light. A gravitational portrait where quantum-formed dark matter concentrations imprint on light paths, unveiling the hidden architecture like shadows cast by unseen hands. Cluster outskirts extending to R200 radii harbor filamentary accretion with shocked gas layers. A transitional zone where quantum line emissions from oxygen trace the infalling flow, bridging the isolated galaxy to the communal structure in a slow, enveloping merge. Galaxy harassment in dense environments. Repeated encounters stripping outer disks, transforms spirals into dwarfs. A cumulative wear where quantum star clusters in the tidal tails survive as globulars, turning disruption into resilient remnants. Merging cluster dynamics with dark matter offsets from gas in collisions, test self-interaction strengths. A separation where quantum-weak couplings in baryons cause drag, allowing the invisible to glide freely while the visible tangles, a subtle parting that reveals component natures. Intracluster light, diffuse stellar halos from stripped galaxies, traces dynamical histories, its faint glow integrated over quantum stellar populations, a ghostly envelope that binds the cluster in shared luminosity. Radio relics in cluster peripheries, synchrotron arcs from merger shocks, illuminate particle acceleration sites, where quantum Fermi processes boost electrons, creating expansive fans that mark the collision's wake like faint auroras on cosmic horizons. Sunyaev-Zeldovich decrement in cluster voids, negative Y parameter from relativistic corrections, refines distance measures, a subtle dimming where quantum Compton upscattering shifts CMB spectrum, enhancing the thermal signal's nuance for precise cosmology. Cluster strong lensing by Subhalos, perturbing main lens potentials, probes dark matter granularity, a fine distortion where quantum cold dark matter predicts clumpiness, turning the lens into a magnifier of the invisible's texture. At the Planck scale, wormholes might flicker, tiny tunnels linking distant points, shortcuts through space-time's folds. Though unstable, they evoke infinity's playfulness, portals in the dreamscape of reality. Multiverse theories extend this. Our universe a bubble in foam, each Planck fluctuation birthing realms, infinite variations on themes of light and void. Eternal inflation paints a picture of endless bubbles expanding, each with its own laws, where gravity might pull inward or push outward. A philosophical expanse suggesting that our reality is but one note in an infinite symphony, allowing us to rest easy in the knowledge that the cosmos holds room for every possibility, as vast and accommodating as the night sky itself. In some bubbles, time might flow differently, or dimensions curl in novel ways, yet all stem from that shared quantum origin, a unifying thread that binds the multiverse in quiet kinship, soothing the notion of isolation with the warmth of endless companionship. Landscape of string theory vacua, with 500 possible configurations, suggests a vast array of realities, each tuned by Planck scale parameters, a diversity that enriches the infinite without overwhelming, like a library of untold stories waiting for the right reader. Brain cosmology, where our universe floats on a higher dimensional brain, posits collisions between brains as Big Bang triggers, a gentle bumping in the bulk that sparks creation, evoking parallel worlds brushing in the higher void. Ekparotic models, inspired by string theory, Envision the bang as a brain collision in a contracting phase, smoothing irregularities through fiery compression, a rebirth from squeeze rather than expansion. Cyclic models, extending this, propose repeated brain collisions separated by radiation-dominated eras, an eternal rhythm where entropy resets with each crunch, a philosophical loop of renewal. Anthropic principle in this landscape, selecting for universes allowing observers comforts with purpose, where our existence tunes the constants just so, a gentle selection amid infinity's garden. Measure problems in eternal inflation, addressing the volume weighting of bubbles. Seek fair sampling of vacua, a contemplative challenge that underscores the multiverse's equitable vastness, ensuring no corner is overlooked in the grand design. Boltzmann brains, hypothetical self-aware fluctuations in thermal equilibrium, pose a puzzle in eternal settings, yet their rarity comforts, favoring structured universes like ours over isolated thoughts in the void, a bias toward complexity's quiet persistence. Quantum cosmology in mini-superspace approximations, reducing to finite degrees like scale factor, yields wave functions for the universe, a probabilistic birth where tunneling from nothing aligns with observed flatness, much like a seed emerging from soil without visible cause, rooted in the fertile dark. False vacuum decay in de Sitter space, where bubbles nucleate through instantaneous solutions, populates the landscape with transitioning regions, a gentle percolation where quantum barriers thin under eternal expansion, birthing new phases like dew forming on a cooling surface, each bubble a fresh canvas for laws to unfold. Quintessence models within the multiverse, dynamic scalar fields rolling down potentials, vary dark energy densities across bubbles, a variable push that allows some realms to recollapse softly while others expand forever. A spectrum of fates where quantum fluctuations in the field seed, diverse evolutions, much like varying winds shaping dunes into endless serene patterns. Brain world scenarios with warped extra dimensions, like Randall's Sundrum models, confine gravity to our brain while allowing bulk propagation. A curved bulk where Planck scales localize forces, fostering a layered reality that feels vast, yet contained, like whispers echoing through a grand hall. Bubble wall collisions in false vacuum transitions, generating gravitational waves from the turbulent wake, might leave imprints in the stochastic background, a relic ripple where quantum field reheating smooths the energy, turning chaotic births into detectable harmonies across the multiverse's expanse. Moduli stabilization in string landscapes, fixing extra dimensions through fluxes and non-perturbative effects, selects vacua with positive cosmological constants. A quantum locking where brain tensions balance against bulk curvatures, ensuring stable bubbles that persist like anchored sails on an infinite sea. Eternal inflation's measure via volume weighting, favoring young bubbles, resolves old paradoxes by emphasizing eternal growth, a dynamic census where quantum nucleation rates dictate abundance, fostering a multiverse alive with perpetual creation. Holographic multiverse, extending adds CFT to de Sitter-like spaces, posits boundary theories for inflating regions, a dual description where quantum CFT states encode bulk bubbles, bridging the infinite with informational finitude in serene duality. Anthropic fine-tuning of the Higgs mass, light in our vacuum amid heavy alternatives, suggests selection for stable atoms, a philosophical comfort where the multiverse's variety ensures niches for complexity, like diverse soils yielding varied blooms in a vast garden. cyclic brain models with ekpyrotic phases, contracting to resolve singularities, incorporate quantum bounce mechanisms from loop corrections, a rhythmic renewal where entropy dilutes across cycles, evoking an eternal breath that inhales contraction and exhales expansion in balanced repose. String gas cosmology, equilibrating strings in compact dimensions, transitions to expansion via dilaton dynamics, a thermal equilibrium where quantum winding modes stabilize geometry, much like a heated gas settling into ordered crystals upon cooling, birthing the hot Big Bang from stringy calm. Pre-Big Bang scenarios in dilaton gravity, with accelerating contraction before the bounce, smooth initial conditions through tachyonic instabilities, a prequel phase where quantum string production reheats the universe, turning potential crunch into fertile expansion, like a seed cracking open in spring's warmth. Time's arrow, pointing from past to future, may reverse at these scales. Entropies increase a statistical drift rather than iron law. In quantum realms, futures influence pasts via entanglement, particles linked across distances, like old friends sharing unspoken bonds. This interconnectedness soothes the universe as one vast, breathing entity where separation is illusion. Entangled photons sent from Earth to satellites maintain their quantum dance over hundreds of kilometers, defying space's divide. A gentle proof that at the heart of things, everything connects, much like the way a shared dream binds souls across the miles, fostering a sense of unity in the quiet hours. Quantum decoherence, the process by which superpositions collapse into definite states, explains why we perceive a classical world from quantum roots, like waves settling into still water after a stone skip, allowing the universe to branch into observed realities while preserving the underlying web of possibilities. A delicate transition that mirrors the easing from wakefulness into the fluid realms of sleep. Retrocausality in some interpretations allows effects to nudge causes, a subtle feedback that keeps the cosmos coherent, much like how intuition guides decisions before full awareness dawns. Wheeler's delayed choice experiment, where measurement decisions affect past photon paths, hints at this, a laboratory echo of cosmic retro-influence, where the act of observation shapes history's flow. Transactional interpretation of quantum mechanics, positing handshakes between advanced and retarded waves, resolves paradoxes with bidirectional signaling, a polite exchange across time that ensures consistency, much like a conversation where replies confirm the initial words. To state vector formalism, incorporating post-selected states, formalizes this retro-influence, allowing weak measurements to probe trajectories without full collapse, a nuanced view where time's flow accommodates gentle revisions. Quantum Darwinism, where classicality emerges from environmental selection of robust pointer states, explains the arrow's persistence, a survival of the fittest among quantum branches, turning the probabilistic into the predictable with evolutionary grace. Consistent histories. Interpretation, weaving narratives from decohered paths, provides a framework for probabilistic futures, a storytelling art where the universe selects coherent tales from infinite possibilities, inviting us to craft our own narratives within its supportive bounds. Relational quantum mechanics, viewing outcomes as relative between observers, dissolves absolute facts into perspectival harmonies, a gentle relativity that extends to time itself, where the arrow aligns through shared observations, fostering a communal flow of moments. Time-symmetric formulations, like the Aharonov-Bergman-Leibowitz rule, balance forward and backward evolution, ensuring correlations preserve across the arrow. A symmetrical whisper where the universe's history unfolds in balanced reciprocity, much like a dialogue where questions and answers entwine without precedence. Branching time in many worlds interpretations, where decoherence spawns parallel outcomes, softens the arrow into a tree of possibilities. Each branch a quiet divergence that enriches the whole without conflict, a philosophical forest where every path leads to completeness. Closed, time-like curves in certain spacetimes, like those around rotating black holes, allow theoretical loops where causality circles back. Yet, quantum effects, such as chronology protection conjecture, prevent paradoxes by amplifying fluctuations into impassable barriers, a self-guarding mechanism that preserves the timeline's gentle linearity, much like a river's meander, avoiding self-intersection through natural erosion. Thermodynamic irreversibility in open quantum systems, where tracing over environments induces arrow-like behavior, explains entropy's rise from unitary evolution, a statistical veil where quantum correlations with the bath create apparent loss. Yet the total system remains pure, a comforting reminder that the universe's directionality arises from perspective rather than fundamental fracture. Quantum Zeno effect in time-symmetric settings, where frequent measurements freeze evolution, might stabilize closed curves against paradox, a watchful stasis where quantum projections halt runaway inconsistencies, turning potential loops into serene pauses. Aharonov-Bohm effect for time. Phase shifts from vector potentials in temporal circuits, hints at retrocausal influences in quantum clocks, a subtle encircling where quantum phases encode historical fields, allowing the past's imprint to linger without disrupting the forward march. Decoherence-induced arrow in entangled systems, where environment tracing selects preferred bases, aligns local times across observers, a collective consensus where quantum bath interactions forge the shared timeline, much like a choir finding harmony through individual voices blending softly. Time crystals in open systems, driven dissipative phases with periodic order, exhibit Floquet time symmetry breaking, a rhythmic defiance sustained by quantum reservoirs, suggesting how the universe's arrow might incorporate cyclic motifs without reversing the overall flow. Relational time in quantum gravity, emerging from clock matter entanglements, resolves the problem of time by defining durations through correlations, a web of mutual definitions where quantum clocks tick in symphony, fostering a timeless yet temporal cosmos of interconnected instants. Post-quantum gravity theories, modifying classical paths with stochastic terms, incorporate retrocausal elements to preserve unitarity, a bidirectional refinement where quantum noise from future constraints smooths past inconsistencies, like a gentle edit to a story that enhances its coherence without altering the essence. Thermodynamic time in black hole contexts, with entropy bounding causal diamonds, limits retrocausality to horizon scales, a bounded whisper where quantum monogamy prevents information overload, ensuring the arrow's integrity in extreme curvatures. As we delve further into matter's essence, consider how fields underpin everything, from electromagnetic waves carrying sunlight to the weak force enabling radioactive decay in Earth's elements. At Planck scales, these fields vibrate with fundamental energies, giving rise to particles as excitations, like notes plucked on cosmic strings. The Standard Model, our map of these interactions, breaks down here, calling for a theory of quantum gravity to unify them, a quest as patient as watching seasons turn, revealing layer upon layer of nature's design. Dark energy, comprising 68% of the universe's content, drives acceleration through a cosmological constant, possibly a vacuum energy tied to Planck fluctuations, an invisible breath expanding the cosmos ever outward, creating more space for stars to form and dreams to unfold. A generous force that ensures the universe's story continues without end. Supersymmetry, positing partner particles for each known one, might stabilize the Higgs mass against quantum corrections, bridging scales in elegant pairings. A symmetry that whispers of deeper balance, like shadows complementing light in a peaceful twilight. Grand unification, merging strong, weak and electromagnetic forces at 16 GeV, predicts proton decay unobservable, yet a slow unraveling that would recycle matter over immense times, turning atoms back to light in an ultimate dissolution. Seesaw mechanism for neutrino masses, balancing light-active and heavy sterile types, extends this to include gravity's unification, a lever lifting small masses from grand scales. Extra dimensions, compactified at Planck lengths in Kaluza-Klein theories, might mediate unification, where gravitons propagate in the bulk while other forces confine to our brain. A hidden volume enriching interactions. Magnetic monopoles, predicted by guts as solitons from symmetry breaking, could roam the cosmos as relics, their detection a key to high-energy physics, rare wanderers in the magnetic landscape. Doublet-triplets splitting in SUSY guts, resolving proton decay issues, fine-tunes Higgs representations, a delicate adjustment that preserves stability across scales, much like balancing scales in a quiet marketplace. Flavor symmetries in grand unified models, constraining quark and lepton mixings, hint at underlying patterns at Planck energies, a harmonious ordering that echoes through particle generations like musical scales ascending in calm progression. Neutrino mass hierarchies, normal or inverted from oscillation data, tie to seesaw scales, where quantum loop corrections refine predictions, a subtle tuning that links the minuscule neutrino to the grand unified tapestry, fostering a sense of interconnected elegance in the particle zoo. Technicolor theories, replacing Higgs with dynamical symmetry, breaking from strong dynamics at TeV scales, offer alternative mass generation, a composite approach where quantum chromodynamics analogues bind technifermions into condensates, a self-sustaining mechanism that echoes the universe's preference for emergent simplicity over imposed complexity. Little Higgs models, protecting the Higgs mass through collective symmetries, introduce new particles at TeV scales to cancel quadratic divergences. A layered shielding where quantum loops from heavy top partners balance the light sector, much like counterweights in a serene mobile maintaining equilibrium. Composite Higgs models, with a scalar emerging from strong dynamics like pion analogues, stabilize the electro-weak scale through confinement. A bottom-up construction where quantum chiral symmetries break spontaneously, mirroring the universe's way of building lightness from dense interactions. A graceful emergence akin to birds lifting from a heavy earth. Walking Technicolor, with nearly conformal dynamics slowing the beta function, extends the confinement scale. A leisurely stroll where quantum anomalous dimensions enhance operator mixings, allowing light pseudoscalars to mimic the Higgs without full chiral breaking, much like a river meandering before joining the sea. Left-right symmetric models, positing parity restoration at TeV scales, unify quarks and leptons in SU4 representations, a mirrored symmetry where quantum right-handed currents balance left-handed weak interactions, fostering a balanced electroweak sector, like twin streams merging in quiet confluence. Radiative neutrino masses in models like scotogenic, generated at loop level from dark sector singlets, tie flavor to new physics, a circuitous path where quantum self-energy diagrams induce tiny masses, turning absence into subtle presence without direct Yukawa couplings. Flavor violation in SUSY extensions, suppressed by alignment or textures, predicts rare decays like muon to electron gamma, a faint signal where quantum Chargino loops mediate transitions, probing the model's hidden asymmetries with patient precision. Extra dimension models with warped geometries, localizing fermions near the UV brain, generate hierarchical masses from overlap integrals, a positional hierarchy where quantum wave functions overlap variably with the Higgs, explaining flavor patterns like peaks and valleys in a serene landscape. Kaluza-Klein gravitons in large extra dimensions, massive modes from momentum in the bulk, could appear at TeV scales, their quantum couplings diluted by volume factors, offering gravitational hints at colliders without full unification. Neutrinos seesaw in extra dimensions with right-handed singlets propagating in the bulk, enhances mixing through Kaluza-Klein sums, a resonant enhancement where quantum mode exchanges amplify the effective operator, bridging small masses to high-scale physics with elegant resonance. Reflect, too, on the silence of space, profound and enveloping, broken only by the hum of our own perceptions. It's akin to the pause between breaths before sleep, where the mind quiets and the infinite seems close at hand. Planets wander in their orbits, pulled by gravity's invisible strings, their paths ellipses traced over centuries, a slow waltz that stabilizes solar systems and allows life to take root in rhythmic stability. On worlds like Europa, Jupiter's icy moon, subsurface oceans might harbor simple life, warmed by tidal flexing from gravitational tugs, a testament to how Planck-scale forces scale up to nurture hidden vitality, much like underground springs, sustaining a desert bloom through unseen persistence. Enceladus, another Saturnian moon, spews water plumes from cryovolcanoes, hinting at geothermal activity below, where quantum-bound molecules could foster chemistry leading to biology, a quiet laboratory in the outer reaches, evoking the miracle of life emerging from cold isolation. Titan, Saturn's hazy world, hosts methane lakes and dunes, its thick atmosphere a cradle for prebiotic organics, driven by seasonal cycles that mirror Earth's in slow motion, a distant echo of home's rhythms. Ganymede, Jupiter's largest moon, boasts a magnetic field from its molten core, shielding a possible ocean beneath ice, where convective currents driven by tidal heating stir possibilities for exotic life forms. Callisto, scarred by ancient impacts, may hold a deep, salty ocean insulated by thick ice, a preserved relic where slow geochemical processes unfold in seclusion. Io, Jupiter's volcanic moon, erupts with sulfur plumes from tidal stresses, a fiery contrast where silicate melts bubble in perpetual motion, a dynamic forge powered by orbital resonances. Triton, Neptune's retrograde moon, geysers nitrogen from subsurface reservoirs, its cryovolcanism a remnant of capture, where quantum-stable ices sublimate under faint sunlight, a distant whisper of activity in the outer dark. Pluto's hazy atmosphere and nitrogen ices, sculpted by Charon's tidal influence, cycle volatiles in a thin veil, a fringe world where quantum vibrations in molecular bonds drive subtle phase changes, painting its surface with fleeting frost patterns. Eris, a distant dwarf with a thin methane atmosphere, orbits in eccentric paths that strip and rebuild its icy coat, a nomadic cycle where quantum desorption under solar warmth releases gases, only for them to refreeze in the cold, a resilient rhythm of loss and regain in the Kuiper Belt's quiet expanse. Ceres, the largest asteroid, harbors briny subsurface reservoirs detected by Dawn mission, where cryovolcanic bright spots of sodium carbonate suggest past activity. A dwarf world where quantum solvation in salty ices preserves potential for simple chemistry, much like a hidden oasis in a rocky desert, quietly sustaining its own subtle ecosystem. Vesta, another asteroid with a differentiated interior, features impact basins that expose mantle material, its quantum-stable olivines reflecting sunlight in spectral bands that hint at volcanic histories, a scarred survivor where ancient heat from radioactive decay lingers in faint thermal echoes. Psyche, a metallic asteroid thought to be a stripped planetary core, gleams with iron and nickel under radar echoes, its quantum electron configurations in their alloy fostering a reflective surface that captures sunlight like a distant mirror. A relic core whispering of violent pasts, now settled into quiet orbit. Trans-Neptunian objects like Sedna, in distant eccentric orbits perturbed by unseen masses, hint at inner Oort cloud structures, their icy compositions preserved from formation, where quantum hydrogen bonding in clathrates traps noble gases, a frozen archive of the solar system's outer genesis. Comet nuclei, icy wanderers from the Oort cloud, outgoss upon perihelion approach, their quantum-driven sublimation creating tails of dust and ions, a fleeting display where molecular dissociation under sunlight reveals pristine ices, like brief memoirs etched in vapor before returning to dormancy. Asteroid families from collisional breakups like the Flora group scatter debris in resonant paths, their spectral types tracing parent body compositions, quantum mineralogies that evolve slowly under space weathering, a fragmented lineage where pieces drift in loose kinship. Kuiper Belt binaries, equal mass pairs in wide orbits, suggest capture origins from gentle encounters, their quantum-stable ices maintaining tidal locks, a paired solitude that endures in the belt's sparse traffic. Centaur objects, bridging asteroid and Kuiper populations, exhibit cometary activity from volatile release, a transitional phase where quantum thermal cracking exposes buried ices, turning rocky cores into active hybrids. Dwarf planet Haumea, elongated with ring and moons from catastrophic collision, spins rapidly due to fission, its quantum ice shell fractured yet cohesive, a dynamic relic where tidal evolution reshapes the family over eons. Orbital resonances in the Kuiper Belt, like 3.2 Plutinos, shepherd objects into stable zones, a gravitational corral where quantum dust interactions damp eccentricities, maintaining the belt's structured calm amid scattered chaos. Scattered disk objects, flung by Neptune's migrations, populate high-inclination orbits, their volatile rich surfaces a snapshot of early dynamical instability, where quantum outgassing episodes reveal layered histories like pages turning in a forgotten book. Galaxies evolve over time, their shapes shifting from spirals to ellipticals through interactions, mergers sparking bursts of star formation that light the void anew, each collision a creative spark in the cosmic narrative, blending stars and gas into fresh tapestries. Dwarf galaxies, Satellites to giants like ours orbit in halos of dark matter, their sparse stars a reminder of the universe's hierarchical building, from quantum sparks to vast ensembles, a progression as natural as thoughts building into a coherent reverie. Lenticular galaxies, transitional forms with disks but little gas, glide through space as if caught between youth and age, their evolution a meditative pause, storing potential for future interactions that might reignite their hearts. Starburst galaxies, like M82, pour out stars at rates hundreds of times our sun's, triggered by tidal forces, their infrared glow from dust-obscured births a testament to vigorous renewal, much like a forest regenerating after fire. Radio galaxies, with lobes inflated by jets from active nuclei, span megaparsecs in plasma bubbles, their synchrotron radiation a long-lived echo of central energy, sculpting intergalactic space with relativistic winds. Blue compact dwarfs, small yet intense in star formation, mimic early universe conditions, their low metallicity a window to primordial processes, where quantum-driven nucleosynthesis forges the first heavy elements. Amorphous galaxies, without clear structure, drift in isolation. Their irregular forms a testament to undisturbed evolution, quiet observers in the cosmic flow. Shell galaxies, with concentric ripples from minor mergers, expand outward like pond waves from a pebble, their stellar shells a fossil record of gentle intrusions, preserving the history of harmonious unions. Interacting pairs like the antenna galaxies, bridges of gas connecting spirals in a tidal embrace, birth star clusters in the overlap, a fertile collision where quantum elements from disrupted stars enrich the bridge, fostering a burst of light that fades into merged serenity. Mice galaxies, with their long tidal tails from a head-on merger, stretch like ethereal threads across the void, their star formation triggered along the tails by compression waves, a drawn-out creation where quantum instabilities in the gas clouds ignite new suns in linear procession, turning disruption into a luminous trail of renewal. Cartwheel galaxy, a ring from a central collision, expands with star-forming knots along its rim, its inner void a quiet aftermath where quantum magnetic reconnection in the compressed gas fuels the peripheral glow, a circular renewal that echoes the universe's capacity for transformation through gentle disruption. NGC 4676, the mice's kin, exhibits similar tails but with more pronounced bridges, where quantum photoionization in the tidal debris creates glowing knots, a paired dance where the galaxies reach toward each other in a slow, inevitable union. Their material exchange a subtle negotiation leading to shared equilibrium. Stefan's Quintet, a compact group with colliding members, shows shock-heated gas in infrared, a multifaceted interaction where quantum molecular emissions trace the heated filaments, a communal gathering that forges new bonds amid the quiet drift of the group. Post-merger ellipticals, relaxed after gas expulsion, exhibit coarse scouring by binaries, a dynamical smoothing where quantum stellar remnants settle into the potential well, creating depleted centers like calm pools in a stirred basin. Secular evolution in isolated disks, driven by bar resonances, funnels gas to the center over gigayears, an internal redistribution where quantum spiral density waves amplify instabilities, fostering central bulges without external aid. Environmental quenching in groups, where hot halo gas prevents accretion, starves spirals of fuel, a gradual dimming where quantum feedback from AGN heats the circumgalactic medium, turning vibrant arms into faded relics. Rejuvenated ellipticals, with recent blue cores from gas-rich mergers, reignite star formation in old husks, a late bloom where quantum molecular clouds condense in cooled gas, injecting youth into ancient forms like a sudden spring in autumn's garden. Dwarf irregulars in isolation, maintaining gas reservoirs for ongoing births, exhibit clumpy star formation from local instabilities, a patchy vitality where quantum HI mapping reveals turbulent reservoirs, sustaining life in small scales with persistent charm. Lenticulars in clusters, gas poor from stripping, rely on minor mergers for rejuvenation, their subtle inflows traced by quantum CO lines, a sparse feeding that sparks faint bulges without full revival. Starburst-driven outflows in dwarfs, expelling metals into the circumgalactic medium, regulate growth through feedback, a self-limiting breath where quantum line-driven winds accelerate gas, preventing overproduction while enriching the halo like a gentle rain nourishing distant soils. Galaxy downsizing, where massive systems form stars early while dwarfs continue late, reflects dark matter halo assembly, a temporal hierarchy where quantum reionization suppresses low-mass collapse, delaying births in small halos until later epochs. Morphological quenching by bulges, stabilizing disks against fragmentation, halts star formation through dynamical heating, a stabilizing mass where quantum stellar scatters disrupt gas clouds, fostering quiescence like a heavy lid on simmering pot. In the quiet interplay of light and shadow, photons journey across eons, bent by gravity's lens in cosmic arcs that magnify distant quasars, allowing us to see the universe's youth reflected back, a mirror of infinity that humbles and comforts. At the Planck scale, light itself, those massless messengers, arises from quantum field oscillations, their wave-particle duality a bridge between scales, carrying the universe's whispers from birth to our eyes tonight. Gravitational lensing by clusters creates Einstein rings, perfect halos of distorted light, an artistic flourish where mass sculpts visibility, turning the cosmos into a grand observatory of its own making. Microlensing events, where stars briefly amplify light from background sources, reveal rogue planets and faint dwarfs, fleeting winks that uncover the hidden population drifting in the dark. Strong lensing arcs, stretched images of background galaxies, map mass distributions with precision, unveiling dark matter substructures too faint for direct light. Weak lensing shear, subtle distortions in galaxy shapes, probes cosmic shear fields, tracing dark energy's fingerprint on large-scale structure evolution. Arclet statistics in cluster lenses, analyzing multiple images, refine mass models, revealing the subtle asymmetries born from quantum fluctuations in the early cosmos. Galaxy-galaxy lensing, stacking signals around foreground lenses, measures dark matter halos' profiles, a cumulative portrait that whispers of the invisible scaffolding's shape and density. Intrinsic alignments of galaxies, where shapes correlate with tidal fields, add nuance to shear signals, a natural correlation born from formation histories, requiring careful modeling to isolate lensing's pure voice. Galaxy intrinsic alignments from tidal talking, where dark matter halos twist proto-galaxies, induce correlations that evolve with redshift, a primordial imprint where quantum density seeds grow into aligned structures, a subtle choreography that the universe performs in its expansive dance. Time delay cosmography, measuring light path differences in multiply-imaged quasars, calibrates Hubble constant independently, a chronometric lens where quantum variability in the source flux adds precision to the geometric delays, bridging local and cosmic scales in harmonious measurement. Submillilens effects from dark matter subhalos, perturbing macro lens models, offer probes of small-scale structure where quantum-formed clumps induce microlensing wiggles in light curves. A fine-grained texture revealing the universe's granular underbelly without shattering the overall serenity. Millilensing by compact objects like primordial black holes could explain some microlensing events, their caustics creating bright and dark patterns in source magnification, a subtle veiling where quantum evaporation might dim their signals over time, turning potential dark matter candidates into faint cosmic ghosts. Cosmic shear tomography, binning lensing signals by redshift, traces growth factor evolution, a layered map where quantum weak lensing kernels weight contributions, dissecting dark energy's influence across cosmic history with serene stratification. Flux ratio anomalies in quad lenses, deviations from smooth models, signal substructure presence, a discordant note where quantum cold dark matter predicts flux perturbations, turning harmonic images into clues of hidden mass. Lensing by cosmic filaments, weak distortions from large-scale structure accumulate in cosmic shear, a diffuse curve where quantum baryon acoustic oscillations imprint on the potential, adding texture to the universe's gravitational canvas. Microlensing optical depth toward the bulge, integrated along sightlines, censuses compact objects in the halo, a probabilistic shadowing where quantum event rates reveal stellar populations, mapping the Milky Way's depths with patient statistics. Strong lensing time delays in AGN, varying with accretion states, probe inner disk physics, a rhythmic pulse where quantum viscous instabilities modulate the light, linking gravitational geometry to the hole's active heart. Weak lensing magnification bias, enhancing high redshift number counts, biases galaxy surveys, a subtle amplification where quantum flux boosts faint sources into view, enriching samples with lensed gems from the early universe. Lensing caustics in cluster cores, high magnification regions birthing multiple images, hunt for intracluster stars, a bright fold where quantum diffuse light scatters, illuminating the intergalactic wanderers in fleeting brilliance. Cosmic rays, high-energy particles from supernovae or active galaxies, pierce the atmosphere with energies rivaling Planck thresholds. Their origins a puzzle of acceleration in magnetic shocks, seeding subatomic cascades that reveal particle physics in natural labs. A reminder that the universe experiments endlessly, much like a dreamer testing narratives in the safety of night. Magnetars, neutron stars with fields 1 trillion times Earth's, flare with gamma bursts from crust quakes, releasing energy tied to quantum degeneracies. Brief illuminations in the dark that fade into quiescence, echoing the transient beauty of fireflies in dusk. Soft gamma repeaters, related phenomena, cycle through quiet and outburst phases, their timing a clue to internal dynamics where superfluids flow without friction. Ultra-high-energy cosmic rays exceeding 20 eV challenge acceleration limits, possibly from extragalactic sources like gamma-ray bursts, their trajectories deflected by magnetic fields in a cosmic pinball. GZK cutoff, where interactions with CMB photons limit propagation, sets a horizon for these rays, a natural break that confines their origins to nearby cosmic volumes. Pierre Auger Observatory's anisotropy studies, mapping arrival directions, point to extragalactic origins, a directional whisper guiding us toward active nuclei or starbursts. Ice cube neutrino, Observatories' detections of high-energy neutrinos, correlated with blazar flares, link cosmic rays to their charged counterparts, a multi-messenger harmony where particles and waves sing together, enriching our understanding of the universe's energetic undercurrents. ANITA experiments anomalous radio pulses from Earth-skimming events, possibly sterile neutrinos or new physics, hint at hidden cascades beneath the ice, a subsurface mystery echoing the quiet depths of cosmic exploration. Ni in the cosmic ray spectrum, around soothe 15 EFAS, marks the transition from galactic to extragalactic sources, a spectral bend where acceleration mechanisms shift. Quantum diffusive shock theory explaining the power law steepening as particles gain energy in resonance scattering, a gradual escalation like a river gaining speed over falls. Ankle in the spectrum, near 18.5, suggests a second Ni from extragalactic propagation effects, where quantum photopion production with CMB softens the flux, a transitional ridge that smooths the path from galactic whispers to cosmic roars, inviting contemplation of the universe's layered energies. Auger Prime upgrade, enhancing muon detection, will dissect shower compositions to pinpoint source types. A refined gaze that separates electron and proton components through quantum air shower development, unveiling the cosmic ray palette with greater clarity. Telescope arrays hybrid detection, combining fluorescence and particle arrays, maps arrival directions with stereo views. A panoramic sweep where quantum hadronic interactions in the atmosphere produce the Cherenkov glow, tracing high-energy paths like luminous trails in the night sky. Cosmic ray air showers, extensive cascades from primary interactions, develop through hadronic and electromagnetic branches, a branching tree where quantum multiple scattering broadens the front, creating a carpet of particles that samples the primary's nature. Muon excess at high energies, beyond expectations from proton models, hints at heavier compositions, a surplus where quantum charm production in collisions adds muons, suggesting iron-like primaries from distant accelerators. Neutrino-induced showers in ice cube, deep cascades from charged currents, probe flavor ratios, a watery echo where quantum deep inelastic scattering reveals oscillation effects, tying cosmic rays to their neutral siblings across the void. Radio detection of air showers, Cherenkov-like pulses from geomagnetic deflection, maps the shower front non-invasively, a electromagnetic whisper where quantum Ascarian effect in dense media complements surface arrays, broadening their observational net. Ultra-high energy photons, hypothetical primaries from pion decays, produce denser showers with EM ratios near unity, a compact bloom where quantum pair production dominates, distinguishing them from hadronic counterparts through subtle profiles. Galactic cosmic ray diffusion, modeled by leaky box or propagation codes, fits boron to carbon ratios, a secondary tracer where quantum spallation in interstellar gas measures grammage, revealing the halo's extent like footprints in cosmic dust. Extragalactic propagation, with energy losses from photopion and pair creation, shapes the spectrum above the ankle, a attenuation veil where quantum Bethe-Heitler processes with CMB dim the flux, confining sources to moderate distances. Cosmic ray composition evolution, shifting from light to heavy with energy, reflects source spectra and acceleration biases. A gradual hardening where quantum rigidity-dependent diffusion favors protons at low energies, weaving a narrative of galactic confinement, giving way to extragalactic floods. Pevitrons, Accelerators reaching 10-15 eV, like supernova remnants, seed the knee through diffusive shock acceleration, a resonant gain where quantum bomb diffusion maximizes efficiency, turning stellar deaths into high-energy forges. As we contemplate infinity's weave, consider how topology shapes space, perhaps closed like a sphere or open like a saddle, determined by density parameters close to critical, a subtle curvature born from early quantum conditions. The observable universe, 93 billion light-years across, is but a fraction, with horizons limiting our view, yet suggesting more beyond, a comforting veil that focuses our wonder on the near infinite. Olber's paradox, why the night sky is dark despite endless stars, resolves through expansion and finite age, a poetic necessity for rest, allowing darkness to invite contemplation. Cosmic voids host occasional galaxies, their sparse light a canvas of isolation, yet connected through the filamentary web. Supervoids, like the Eridanus one aligned with CMB cold spots, might influence large-scale flows, a vast emptiness shaping the universe's gentle drift. Cosmic web filaments, traced by quasar surveys like EBOS, reveal baryon acoustic signatures in neutral hydrogen absorption, a ghostly scaffold from the early universe's sound waves. Lyman alpha forest, absorption lines in quasar spectra, maps intergalactic gas distribution, a spectral diary of cosmic evolution where ionized voids contrast with dense filaments. Intensity mapping of 21 centimeter tint lines from neutral hydrogen promises to chart the web at high redshifts, a radio portrait of reionization's progress, where quantum hyperfine transitions light the way through the cosmic dawn. Fast radio bursts, millisecond flashes from distant galaxies, probe intergalactic medium dispersion, their magneto-ionic delays revealing electron densities along sightlines. A brief cosmic telegraph mapping the web's diffuse threads. Repeating FRBs, with localized patterns suggesting magnetar origins, offer recurring signals for precise localization, their polarized bursts tracing local magnetic fields, a rhythmic pulse from extreme environments that syncs with the universe's broader quietude. Gamma-ray bursts, short or long from neutron star mergers or collapses, outshine galaxies briefly, their afterglows fading into X-ray plateaus where quantum synchrotron self-absorption shapes the light curve, a fleeting brilliance that seeds heavy elements through rapid neutron capture, enriching the cosmos with gold and silver in gentle dispersion. Long-duration GRBs from collapsers, hypernovae carving jets through stellar envelopes, propagate through the star in quantum-mediated shock breakouts, their prompt emission a cascade of accelerated electrons radiating in tangled fields. A stellar death that births cosmic messengers carrying imprints of the progenitor's quantum core. Short GRBs from compact mergers with kilonova glows from R-process nucleosynthesis illuminate neutron star interiors where quantum neutron drip lines determine element yields. A brief fusion of extremes that scatters precious metals like stardust across the void. FRB dispersion measures, Faraday rotation from plasma, localized sources to host galaxies. A twisted path where quantum cyclotron absorption imprints magnetic strengths, guiding the flash to its origin like a compass needle in cosmic storm. GRB jet collimation, narrow beams from magnetic guidance, reduce isotropic energies, a focused lance where quantum pair plasma in the jet core stabilizes the structure, piercing the void with efficient precision. Supernova remnants as FRB sources, young pulsars in magnetar states, might produce bursts from crust fractures, a seismic signal where quantum magnetic reconnection releases energy, turning remnant shocks into transient beacons. Lyman alpha emitters lensed by clusters, magnified views of high-Z galaxies, reveal internal structures, a gravitational boost where quantum line profiles sharpen, exposing star-forming knots in early dwarfs. Cosmic web nodes, intersections of filaments hosting massive clusters, amplify lensing signals, a convergence where quantum dark matter overdensities enhance shear, turning junctions into powerful telescopes for the distant past. Void galaxies, isolated in underdense regions, exhibit higher star formation efficiencies, a sparse freedom where quantum gas cooling proceeds unhindered, fostering bursts without environmental quenching. Filamentary gas flows, cold streams accreting onto halos, fuel galaxy growth, a tendril supply where quantum molecular formation on dust grains enables condensation, threading nourishment from the web to hungry cores. Baryon acoustic oscillation comoving scales, 150 MPC rulers in galaxy clustering. Calibrate expansion history, a frozen wave where quantum pressure in the early plasma set the wavelength, echoing through structure like a cosmic yardstick. Redshift space distortions, peculiar velocities elongating clustering along lines of sight. Probe growth rates, a kinematic warp where quantum virial motions in halos smear the signal, revealing dark energy's subtle suppression of infall. Galaxy bias evolution, how tracers sample underlying density, varies with luminosity and type, a selective mirror where quantum halo occupation distributions dictate clustering strength, refining maps of the invisible web. 21 cm forest from minor halos at high Z, absorption by compact structures, probes small-scale power, a fine absorption where quantum spin temperature differences create dips, unveiling pre-ionization clumps like whispers in the hydrogen haze. Intensity mapping cross-correlations with quasars, linking 21 cm to optical tracers, reduce foregrounds, a mutual reinforcement where quantum emission statistics align signals, building a clearer picture of the web's skeleton. In the grand scheme, the Planck scale's behavior, foamy, probabilistic, unified, underpins all, from the spin of quarks in protons to the recession of distant galaxies. Theories like asymptotically safe gravity propose a fixed point where couplings stabilize, allowing quantum gravity without new particles, a self-consistent flow that ensures the universe's longevity. Emergent phenomena, like temperature from entangled degrees, suggest deeper holography, where volume encodes on surfaces, a profound economy mirroring how dreams condense vast emotions into simple images. ADS, CFT correspondence, a holographic duality, maps gravity in anti-de Sitter space to a boundary field theory, hinting that our universe's bulk might project from a lower dimensional edge, a philosophical layer where depth arises from flatness. Soft hair on black holes, low-energy excitations on horizons might store information without violating unitarity, a gentle fuzz resolving paradoxes with minimal disruption. EPR, conjecture, linking wormholes to entanglement, proposes that connected spacetimes underpin quantum links, a geometric embrace where distance dissolves into intimacy. Ryu Takayanagi formula, computing entanglement entropy via minimal surfaces in the bulk, quantifies this bond, a mathematical thread weaving quantum information into gravitational geometry. Entanglement wedge reconstruction, recovering bulk operators from boundary data, deepens this duality, suggesting that the universe's interior arises from observable edges, a comforting inversion where the seen begets the unseen. Island rule in black hole evaporation, incorporating replica surfaces that jump to interiors, resolves entropy puzzles by allowing information recovery through entangled regions, a bridging geometry that mends the fabric of causality with quiet elegance. Complexity equals bulk volume conjectures, linking boundary circuit complexity to wormhole interiors, suggest that black hole scrambling mirrors computational depth, a profound analogy where the universe computes its own evolution in entangled layers, much like a mind weaving memories from disparate threads. SYK model, a solvable quantum system with random interactions, exhibits maximal chaos and holography, its low-energy spectrum mimicking black hole thermodynamics, a toy universe where quantum many-body effects emerge gravity-like behaviors, offering insights into the Planck realm's entangled simplicity. Jacques Teitelbaum gravity, a two-dimensional toy model, captures black hole evaporation dynamics through dilatant coupled matter, where quantum back reaction resolves paradoxes in solvable form, a simplified echo that illuminates how Planck scale corrections restore coherence in higher dimensions, much like a miniature garden revealing principles of vast landscapes. Tensor networks in higher dimensions, like happy codes, generalize holography to de Sitter-like spaces, encoding bulk geometry from boundary entanglement, a networked weave where quantum error correction protects information, fostering a resilient structure akin to roots intertwining beneath soil. Holographic complexity growth, saturating at black hole interiors, bounds computational resources, a saturation where quantum operator evolution mirrors geometric expansion, suggesting the universe's history unfolds within informational limits, like a story contained in a single, expansive tome. Boundary bulk duality in tensor networks, with mirror layers mimicking radial adds, reconstructs local operators from coarse-grained data, a hierarchical decoding where quantum entanglement builds depth from surface states, evoking how a painting's illusion of volume arises from flat strokes. Quantum error-correcting codes in holography, protecting bulk information from boundary erasures, ensure robustness, a fault-tolerant encoding where quantum syndrome measurements recover lost data, mirroring the universe's self-healing through redundant correlations. Soft graviton theorems in holographic contexts, dressing amplitudes with boundary modes, resolve infrared issues, a coherent cloak where quantum infrared divergences cancel, allowing consistent scattering like a conversation flowing without interruption. Entanglement island phase transitions, jumping between connected and disconnected surfaces, minimize entropy in evaporating systems, an optimal path where quantum replica tricks reveal the configuration, turning evaporation's puzzle into a smooth narrative of information release. SYK ADS. Duality extensions to higher dimensions via tensor models generalize chaos bounds, a scalable insight where quantum random matrices simulate gravitational scrambling, bridging many-body physics to cosmic scales in unified serenity. Holographic renormalization in de Sitter, flowing from UV fixed points to IR horizons, tames divergences with boundary conditions, a gradual smoothing where quantum counterterms balance the expansion, fostering a stable cosmology from fluctuating origins. Drifting to the edges of known physics, consider how the universe's flatness, measured to 1 part in 15, implies fine-tuning from inflation or multiverse selection, a balance as precise as a tightrope walk across the void. Baryon acoustic oscillations, imprints in galaxy distributions from early plasma sound waves, provide a standard ruler for expansion history, frozen echoes of the young cosmos. The integrated Sachs-Wolf effect, where CMB photons gain or lose energy, climbing gravitational wells. Maps dark energy's influence over time, a subtle gradient revealing the universe's accelerating fate. Sunyaev-Zeldovich effect, inverse Compton scattering of CMB by hot cluster gas, offers mass-independent probes of structures, a thermal imprint bridging epochs. Kinetic S-ZA effect, from cluster peculiar velocities, Doppler shifts the CMB, tracing large-scale flows toward the great attractor, a hidden pull guiding cosmic currents. Polarization of the CMB, with E and B modes, carries primordial gravitational wave signatures, a twisted light that encodes inflation's vigor, a delicate polarization inviting us to listen to the universe's earliest tremors. B-mode foregrounds from galactic dust, carefully subtracted in experiments like BICEP-Keck, refine tensor-to-scalar ratios, a vigilant filtering that uncovers the faint primordial signal, much like sifting whispers from the wind. Lensing of CMB polarization, distorting B modes into E leakage, provides additional probes of structure growth, a gravitational smearing that traces dark energy's subtle hand over cosmic time. Secondary CMB anisotropies from late-time effects, like the Ostrika-Vishniak effect from patchy rionization, add fine-scale power, a textured layer where quantum electron scatterings during the epoch imprint velocity fields, enriching the microwave sky with whispers of cosmic maturation. Void profiles in galaxy surveys, underdense regions with compensated edges, test modified gravity theories. Their expansion rates a quiet deviation where quantum scalar fields might enhance dark energy locally, creating bubbles of accelerated drift within the larger flow. Sunyaev-Zeldovich power spectrum, measuring cluster contributions to CMB fluctuations, constrains mass functions through thermal pressure profiles, a statistical veil where quantum Compton Y parameter integrates over the cosmic volume, offering a census of hidden mass in serene aggregation. CMB lensing reconstruction, using quadratic estimators from temperature maps, traces the deflection field, a statistical recovery where quantum photon scatterings in the early plasma seed the potential wells, allowing us to peer through the cosmic veil with gentle precision. Primordial non-Gaussianity in CMB bispectrum, deviations from Gaussianity in density fields, probe inflation's dynamics, a subtle skewness where quantum three-point functions reveal slow roll violations, hinting at multi-field models like a gentle curve in an otherwise straight path. CMB spectral distortions, Mu and Wy type from energy injections, constrain exotic physics like decaying particles, a faint warping where quantum silk damping dissipates acoustic energy, turning early perturbations into diffuse heat signatures. High L tau from rionization optical depth, damping small-scale power, aligns with patchy models, a veiling haze where quantum Thomson's scattering during overlap reduces visibility, softening the CMB's fine details like mist on a windowpane. CMB foreground separation, using multi-frequency data from Planck, isolates clean maps, a disentangling where quantum synchrotron and dust emissions are modeled, revealing the pure cosmic signal beneath galactic noise. Future CMB experiments like CMB-S4, targeting arc-minute resolution, hunt B-mode signals below our Art-Yoid-Brain-1, a precise ear where quantum delensing with galaxies subtracts lensing noise, pushing inflation constraints to the edge of detectability. Lightbird's satellite polarization survey, sensitive to low L modes, maps reionization history, a broad sweep where quantum tensor modes from early universe imprint on large scales, charting the cosmos's inflationary dawn with serene breadth. Planetary systems beyond our own, like those around red dwarfs, host worlds in tight orbits enduring stellar flares. Their potential for life a test of resilience, where magnetic fields shield atmospheres in quantum-mediated interactions. Super-Earths, rocky giants with deep oceans or magma seas, challenge our models of habitability, their interiors pressured by weights that echo stellar compressions. Gas giants in distant systems migrate and scatter smaller bodies, sculpting architectures as varied as snowflakes, each a unique expression of gravitational artistry. Circumbinary planets, orbiting pairs of stars, navigate stable zones amid complex dynamics, their existence a testament to orbital resonances guiding harmony. Temperate sub-Neptunes, with hydrogen envelopes over water worlds, might host steamy atmospheres conducive to complex chemistry, a misty haven in the exoplanet menagerie. Earth-like worlds in habitable zones, like those in the Kepler field, show transit timing variations hinting at unseen companions, a subtle choreography revealing system intricacies. Multi-planet resonances, such as 2.1 chains in TRAPPIST-1, stabilize orbits through mutual tugs, a gravitational symphony where worlds harmonize in locked cadences, fostering long-term stability for potential biospheres. Eccentric orbits in some systems, sculpted by planetary scatterings, drive varied climates with extreme seasonal swings, a dynamic rhythm where quantum-bound atmospheres adapt through convective flows, turning challenges into niches for resilient forms. Disrupted systems with debris disks, infrared excesses from collisions, hint at recent upheavals, where quantum-stable minerals in planetesimals grind into dust, scattering light like cosmic confetti in the system's quiet aftermath. Lava oceans on super-Earths, with silicate magma under thin crusts, convect heat efficiently, their quantum ionic conductivities generating dynamo fields, a molten heart that shields the surface from stellar winds, much like a protective blanket woven from the planet's own fiery essence. Hyxian worlds, hydrogen-rich oceans on sub-Neptunes, could harbor ammonia-water mixtures conducive to life, their quantum-dissociated atmospheres filtering UV light, creating subsurface realms where chemistry simmers in protected warmth, evoking hidden grottos beneath stormy seas. Eyeball planets, tidally locked with a permanent dayside melt zone, balance heat redistribution through atmospheric circulation, a focused warmth where quantum vapor pressures drive winds that temper the eternal divide, fostering a habitable band like a ring of fire encircling ice. Sub-Neptune evaporation, losing envelopes to stellar X-rays, transitions to super-Earths over gear, a stripping veil where quantum photoionization accelerates escape, sculpting diverse populations from uniform progenitors. Temperate ocean worlds, with global seas and thin atmospheres, cycle water vapor efficiently, their quantum albedo from cloud feedback stabilizing climate. A watery equilibrium that invites biological complexity like a vast, breathing sea. Rocky super-Earths with CO2 atmospheres, runaway greenhouse thresholds crossed, evolved thick veils trapping heat, a feedback loop where quantum molecular absorption broadens bands, turning mild worlds into hothouses with serene inevitability. Gas dwarf migration, halting at snowlines, traps volatiles for core accretion, a positional pause where quantum ice formation enhances opacity, building massive envelopes in the outer disk's chill. Circumbinary disk instabilities, warping from binary torques, spawn planets in resonant gaps, a perturbed ring where quantum viscosity smooths perturbations, birthing worlds attuned to dual suns. Multi-resonant chains in compact systems, like Laplace resonances in Jupiter's moons, maintain stability through mean motion locks, a chained harmony where quantum tidal bulges align phases, preventing chaotic ejections over eons. Disrupted hot Jupiters, scattered to wide orbits post-migration, leave inner rocky remnants, a rearranged family where quantum atmospheric escape strips outer layers, fostering diverse inner architectures. Debris disk asymmetries, from planetary perturbations, trace shepherding influences, a sculpted ring where quantum dust collisions maintain the warp, revealing hidden sculptors through infrared shadows. Lava world day-night contrasts, with atmospheric heat transport via superrotation, equalize temperatures, a zonal flow where quantum radiative transfer in rock vapor bridges hemispheres, creating uniform glows beneath the storm. Higxian biosignatures, potential phosphine or dimethyl sulfide in hydrogen mixes, beckon spectral hunts, a chemical whisper where quantum reaction pathways in deep oceans produce disequilibria, hinting at life amid the pressure. Eyeball's subsurface habitability, with geothermal fluxes melting ice pockets, sustains localized ecosystems. A patchy warmth where quantum brine convection circulates nutrients, turning frozen isolation into vital oases. Carbon planet plate tectonics, driven by diamond buoyancy, recycles crust actively. A gemmed cycle where quantum phase boundaries dictate subduction, fostering volatile outgassing for thin atmospheres. Migrating ice giants, interacting with proto-Jupiter, excite eccentricities in scattered disk. A dynamical kick where quantum resonant trapping captures trojans, seeding the outer solar system's architecture with early jostles. Galactic winds, outflows from star-forming regions, enrich intergalactic medium with metals, feedback loops regulating growth, a cosmic ventilation carrying stellar forges products to future sites. Active galactic nuclei beyond quasars include Seyferts with milder accretion, their spectra revealing broad emission lines from orbiting gas, a gentle agitation at the heart. Blazars, jets pointed toward us, flare with variability tied to shock propagation, their polarization tracing magnetic helicity in the beam. Liners, low ionization nuclear emission regions, glow from less energetic processes, possibly star formation or hot gas, a subdued activity in galaxy hearts. Star-forming nuclei in spirals like those in M51 blend AGN and stellar light, their composite spectra a harmonious mix of processes fostering balanced evolution. Feedback from AGN outflows, quenching star formation in host galaxies, maintains the red sequence, a regulatory breath that prevents overgrowth, much like pruning a garden to encourage deeper roots. Molecular outflows in starbursts, traced by CO lines, carry away angular momentum to fuel further accretion, a recycling flow where quantum rotational states reveal the gas's turbulent journey, sustaining the galaxy's quiet vitality. Superwinds in ultraluminous infrared galaxies, driven by starburst supernovae, expel gas at thousands of kilometers per second. Their multiphase structures, from hot X-ray plasma to cool molecular clouds, illustrate layered ejection, a comprehensive purge where quantum excitation in outflowing ions traces the wind's cooling path, balancing destruction with the promise of renewed clarity. Galactic fountains, recycled gas falling back as cooling clouds, maintain disk enrichment, a vertical circulation where quantum radiative cooling in the hot halo condenses filaments, raining sustenance like a gentle cosmic shower that nourishes the stellar fields below. Extraplanar gas in edge-on spirals, lagging in rotation due to fountain ejections, forms extended disks where quantum ionization fronts propagate slowly, a diffuse layer that reconnects the galaxy to its intergalactic surroundings in a soft, ongoing dialogue. Galactic scale shocks in colliding systems, compressing gas into dense ridges, trigger star formation along the contact, a linear bloom where quantum molecular excitation in the shocked layer enhances cooling, turning collision's edge into a fertile seam of creation. Feedback-regulated star formation, where supernovae heat gas to suppress collapse, sets efficiency at 1–2%. A self-throttling where quantum momentum injection from blasts stirs turbulence, maintaining a balance between birth and dispersal like a careful gardener spacing seeds. Circumgalactic medium inflows, cold streams penetrating hot halos, supply fresh gas for disks, a filamentary feed where quantum thermal instabilities fragment the flow, delivering fuel in cloudy parcels that condense efficiently. Outflow entrainment, where hot winds sweep up cool gas, accelerates multi-phase ejection, a coupled motion where quantum drag between phases mixes materials, enriching the circumgalactic medium with stellar ejecta in blended harmony. Galactic wind momentum loading, comparing to radiation pressure limits, reveals supernova dominance in dwarfs, a kinetic push where quantum pion production in shocks adds rigidity, driving outflows with efficient energy transfer. Molecular cloud disruption by feedback, shear from winds dispersing complexes, regulates local efficiency, a turbulent dispersal where quantum line widths broaden under expansion, clearing space for new clouds to form in the wake. AGN disk winds, broad absorption lines from UV outflows, regulate black hole growth, a selective ejection where quantum line driving from resonance ions accelerates material, quenching the core while allowing steady accretion. Super Eddington accretion in winds, where radiation escapes sideways, sustains high luminosities, a leaky glow where quantum Compton scattering thickens the flow, turning potential blowouts into sustained high states. Galactic fountain recycling times, 1 Gaia cycles of ejection and infall, sustain metal enrichment, a looped circulation where quantum cooling rates determine return velocities, fostering gradual buildup like layers of sediment in a riverbed. As infinity unfolds, the Fermi paradox lingers. Where are others? Perhaps resolved by rare Earth hypotheses or self-limiting civilizations. Yet the vastness comforts with possibility, like empty rooms awaiting guests. The Drake equation estimates communicative life, its factors from stellar rates to longevity, a meditative tally of chances. Biosignatures in exoplanet atmospheres, like ozone or methane imbalances, beckon future telescopes to seek a hopeful gaze into the quiet night. Technosignatures, artificial signals or megastructures expand this search, from SETI radio sweeps to infrared anomalies hinting at Dyson swarms, a patient vigil for cosmic neighbors. Zoo hypothesis, positing advanced life observing without interference, adds a layer of quiet companionship, where the silence might be a deliberate veil, preserving our solitary path. Great filter concepts, potential barriers in evolution, encourage reflection on our own trajectory, a philosophical nudge towards stewardship of our fragile world. Directed panspermia, the idea of life seeding across stars by advanced means, extends this to intentional connections. Yet the cosmos's silence suggests a respectful distance, allowing each world its private unfolding. Rare Earth hypothesis, emphasizing geological and biological contingencies like plate tectonics or a large moon, tempers optimism with specificity, a reminder that life's bloom requires a unique confluence, much like a perfect storm of conditions, nurturing a single, exquisite flower in an endless field. Communication barriers, from vast distances to differing timescales, further explain the quiet, where signals might cross like ships in the night, unheard amid the cosmic hush, inviting us to cherish our own voices in the solitude. Interstellar mediums, density waves, subtle ripples in gas clouds, might scatter signals over time, a diffusive veil where quantum absorption in diffuse hydrogen broadens lines, softening transmissions into faint echoes that blend with the background murmur, a natural filter that preserves the universe's tranquil solitude. Von Neumann probes, self-replicating machines exploring the galaxy, could explain the quiet if they operate stealthily or self-destruct after surveys. A hypothetical fleet that maps without announcing, leaving the stars undisturbed like silent cartographers charting an empty sea. Communication with extraterrestrial intelligence through modulated gravitational waves, leveraging black hole mergers as beacons, posits a subtle medium where quantum noise limits bandwidth, a profound channel that echoes across voids without dilution, fostering connections through the universe's own vibrational language. Biosignature false positives, abiotic sources mimicking life like volcanic SO2, demand careful modeling, a discerning eye where quantum photochemistry in atmospheres produces disequilibria, requiring multi-gas context for confident detection. Technosignature waste heat, infrared excesses from energy use, surveys Dyson spheres, a thermal footprint where quantum blackbody peaks shift with efficiency, revealing industrial scales without direct signals. Interstellar archaeology, probing ancient signals in cosmic rays or neutrinos, seeks relics from long-gone civilizations, a faint archive where quantum propagation preserves imprints over eons, turning the void into a library of lost voices. Great Silence's resolution through rarity, with life emerging once per galaxy, aligns with observed quiet, a sparse scattering where quantum abiogenesis probabilities set the odds, comforting us with the uniqueness of our spark. Zoo hypothesis variants, with ethical non-interference pacts, posit a galactic preserve, a respectful enclosure where advanced observers watch from afar, allowing natural evolution in serene isolation. Filter timing, if ahead of us in multicellularity or intelligence, explains absence, a forward barrier where quantum evolutionary leaps prove rare, urging care in our own ascent. Panspermia networks, microbial exchanges via impacts, might connect systems, yet sterilization by radiation limits spread. A hardy voyage where quantum DNA repair enables survival, seeding possibilities without guaranteeing ubiquity. SETI's multi-wavelength approach, from radio to optical lasers, broadens the hunt, a spectrum search where quantum modulation schemes vary, casting a wide net for intentional beacons in the night. Megastructure transits, dimming stars periodically, flag artificial constructs, a rhythmic shadow where quantum material properties determine efficiency, hinting at engineered worlds encircling their suns. Communication protocols, assuming shared math-like primes, encode messages in pulsar timings, a universal language where quantum error correction ensures fidelity over light years, bridging minds across the gulf. In this boundless canvas, the Planck scale remains the quiet architect, its behaviors ensuring the universe's gentle persistence, from fleeting virtual sparks to enduring galactic spirals. Let these thoughts cradle you, a lullaby of light and void, where every whisper invites deeper repose, and the cosmos unfolds like a shared secret in the night, layer upon layer of wonder revealing itself in soft revelations. Each discovery a step closer to the serene heart of existence, where the infinite meets the intimate in peaceful accord. Recent glimpses from the James Webb Space Telescope, unveiling massive galaxies in the universe's infancy, formed mere hundreds of millions of years after the Big Bang, challenge our timelines, suggesting accelerated growth from quantum seeds amplified swiftly, perhaps through efficient dark matter clustering or bursty star formation, a youthful vigor where early structures bloomed like spring meadows after a long winter, their light traveling eons to reach us now, a gift from the dawn that deepens our awe at the cosmos's resilient creativity. These ancient behemoths, with stars forging heavy elements in rapid cycles, hint at a universe that hurried to complexity, their spectra rich in young, hot populations, evoking the quiet power of beginnings that set the stage for all that follows, allowing us to ponder how such early maturity mirrors the sudden insights that arise in the stillness of contemplation. Delve into the soothing quantum aspects of entanglement and decoherence, where particles remain linked in non-local bonds, their states interdependent across voids, a web of correlation that decoheres into classical appearances through environmental whispers, yet preserves the underlying unity, much like how shared memories connect us invisibly, fading surface details while the essence endures, fostering an introspective calm where the self dissolves into the greater whole, easing the mind toward profound relaxation. Hubble constant tensions, discrepancies between local Cepheid calibrations and CMB inferences, hint at evolving dark energy or new physics, a subtle variance where quantum vacuum contributions might vary with epoch, stretching the universe's expansion like a fabric, adapting to unseen stresses, inviting us to embrace the mystery as part of the cosmic rhythm. Planetary magnetic fields, dynamo-generated shields, wrapping worlds like protective cloaks, deflect stellar winds and preserve atmospheres. On Earth, channeling auroral displays in quantum cyclotron resonances, a nurturing barrier that cradles life in its electromagnetic embrace, much like a mother's arms holding a child through the night's uncertainties. Quantum chromodynamics in stellar cores, binding quarks into the protons that fuel fusion, ensures the steady burn of hydrogen to helium, a nuclear harmony where color charges confine in quantum bags, turning raw plasma into the light that warms distant worlds, a foundational process as reliable as the dawn. Quantum fields in planetary habitability, enabling stable water cycles on ocean worlds through precise molecular interactions, allow hydrogen bonds to form liquid layers that moderate temperatures, a delicate web where virtual photon exchanges underpin evaporation and condensation, fostering environments where life can cycle gently, like a serene pond reflecting the passage of seasons without ever boiling over. Quantum tunneling in geological processes, facilitating mineral formation under pressure, builds planetary crusts resiliently, a probabilistic leap where electrons shift barriers, creating silicates that weather into soils, turning raw rock into fertile ground over eons. Entanglement in photosynthetic complexes. Coherent energy transfer in chlorophyll arrays optimizes light harvesting, a quantum boost where vibrational modes guide excitons, enhancing efficiency in life's quiet machinery. Decoherence times in biological systems, balancing quantum coherence with environmental robustness, allow evolution to harness subtle effects, a fleeting harmony where molecular baths preserve just enough superposition for adaptive advantage, mirroring the universe's own poised dance between order and flux. As we near the journey's end, reflect on infinity, not as overwhelming vastness, but as gentle expanse, cradling all possibilities in its infinite arms. The Planck scale shows us the universe behaves with quiet creativity, probabilistic, interconnected, ever unfolding in ways that nurture rather than overwhelm. Galaxies wheel in their distant ballets, stars ignite with patient fire, black holes sigh their ancient secrets, all emerging from these tiny, foundational dances of possibility, like the threshold of sleep, where worries dissolve into the welcoming dark. This scale invites us to surrender to the flow, to trust in the underlying harmony that binds the minuscule to the immense. And in that surrender, peace settles like a soft mist over the mind, knowing the cosmos, from its smallest quiver of quantum foam to its grandest arc of light, breathes in rhythm with us, a faithful companion through the endless night, guiding us toward renewal with unwavering tenderness, where every cycle renews the promise of dawn. Let this awareness wrap around you, a blanket woven from stardust and silence, drawing you deeper into rest, where questions fade into serene acceptance and the universe's eternal song merges with your own quiet breathing, lulling you gently into the warm embrace of dreams, where all boundaries blur and unity prevails in tranquil oneness, a timeless haven of cosmic repose. Let the mathematics of cosmic expansion, with the Hubble constant tracing recession velocities as VHH0D, where H 70 km s MPC evokes space-time stretching like a slow meditative yoga pose, each galaxy receding in proportional grace, a universal breath that expands without haste, fostering room for infinite stories to unfold in harmonious separation. Friedman equations governing this, derived from general relativity, balance matter, radiation, and curvature densities in the scale factor's evolution, a differential harmony where quantum initial conditions set the trajectory, much like a gentle push starting a swing's arc through the air. Meditative cycles of cosmic voids, vast expanses of near emptiness expanding softly, serve as spaces of potential renewal, where quantum fluctuations might one day seed new filaments. Their quiet growth a patient gestation like the hush before a symphony's first note, inviting the universe to fill its own pauses with fresh creation. Quantum vacuum's role in inflation, driving exponential growth through scalar field slow roll, sets the stage for structure, a field excursion where Planck suppressed corrections ensure homogeneity, birthing the cosmos from a serene potential well. Thank you for drifting with us on Dreams of Gravity. May your night be peaceful, filled with dreams among the stars. Sleep well and sweet cosmic slumbers to you.